Good afternoon, everybody. We will be starting in a couple of minutes.
Hi, Sridhar.
Hello.
You can see you.
Yeah, I'm
thank
here.
you. Yeah.
Okay.
Thank you. Yeah.
Shall I just try to share my screen?
Yes, please. Yeah.
Okay.
Please go ahead and share.
Yeah, I'm doing that. I'm just doing that. I'll just try to share the computer sound also, and I'll share the entire screen. Okay. All right. Can you see my screen now?
Yes, we can see.
Slide and is it moving?
Yes.
Okay, that's all. Okay, I have one audio, which if it plays fine, if it doesn't play also, it's okay. All right, I'll stop sharing.
Okay.
This is Vipul here. Can you hear me?
Hi, Vipul. This is Jayant here. I just wanted to confirm that you would be handing over to me, right?
Yes, yes, I'll be handing it over to you. Hand it over to Venkatesh.
We can't hear you.
Can you hear me? Can you hear me now?
It's rather faint. I don't know whether others are having the same problem.
I can hear you well. The microphone is the issue.
It is faint, Vipul. Yeah.
Okay, let's do it.
Is it okay?
We can't hear you at all. Very, very low.
Okay, let me just change my headset.
No. Yeah. Yeah, Jayant, we can't hear Vipul.
Right,
Only I
right.
can
Okay,
hear you.
yes.
I'll just change my headset.
Yeah, do that.
Hmm.
Yeah, sound.
So you already have in excess of 100 people on the call.
Yeah.
Yes.
Right. So what is the number that you're expecting?
Registered participants are 1,650.
650. Okay.
That's the registration. Hopefully, good percentage of them will join. Yeah.
Yeah, and this is Sridhar. A quick question. What is the background of the participants? School teachers or industry or?
Majority school teachers.
Okay, thanks.
Yeah.
Hello, is it better now? Can you hear me better?
Yeah, it's a little better now.
Okay. Yeah, Jen. So I will hand it over to you, and then you can hand it over to Venkatesh Raman.
Okay, fine.
Okay, let's just do an energy check. Please respond to the poll. I'll keep it on for another half a minute or a minute. for everyone to answer.
Okay, while everybody is taking the poll, a warm welcome to each one of you here today to the second conference on computational thinking, CTiS 2020. For all of us, the year began with a lot of excitement at CS Pathshala when we declared the Bebras 2019 results and an overwhelming response to the abstracts, the call for abstracts that we received. And the stage was all set. The stage was all set for us to have the physical conference in April at ISER. Unfortunately, the COVID-19 pandemic put all our plans to a stall and we had to postpone it. And here we are today, all of us together to this virtual conference. The journey to the virtual conference has been really exciting and hope all of you enjoy this experience. I know it's not the same as meeting all of you at the conference registration desk amidst all the chaos of us looking for our name tags. But you know, even here, while we are here on the chat box, I'm looking at the comments, seeing who all are joined, and I'm really happy to see all of you here today. We have with us Shanti Pise from ISER Pune and Arun Kadekodi as our organizing committee co-chairs. This event would not have been possible without the relentless effort that they have put in. Over to Shanti.
Hello. Thank you so much, Sonia, for that warm welcome. And on behalf of ISER Pune also, I welcome all of you for this exciting event. I could see that a lot of you are answering the poll question with, you are very much energized and you are very happy to be here. And let's begin with a small presentation here. Arun, can I start my screen share? Hello? Yeah. Hope all of you can see this.
Bars of solid gold.
Yeah.
65,000 kg.
Sonia?
One bar is a kg. Yeah, don't you know this shape? They're measured in kg. There's a reason they're in that shape. So 65,000 kgs. Do experiment. 65, that's not very.
The audio is not playing, Shanti.
Array. Okay. Oh, sorry, the screen share, actually, I'm trying again and let me see. Yeah. Yeah. So I hope now this will play. नहीं हो रहा है अभी, नहीं आ रहा है.
Sonia, should we start? It's past 2
Yeah,
o'clock.
Arun, I think you should start. Yeah.
Yeah. So let me first end this poll and launch, see the results for this. So 36% are energized and 37% happy. I see that 1% is also hungry in this results that we've got. Okay, so let me start the presentation of mine. Yeah, just a minute. Do you see my screen?
Yes,
Yes,
Arun.
Arun, we can start. Yeah.
Yeah. Okay. So this is Arun Kadekodi. A warm welcome to the second conference on computational thinking in schools. Very quickly, I will share some statistics from the first conference that was there in 2019 on April 20th. We had more than 140 delegates, including teachers, principals, and from industry, organizations working in education. And there were delegates from 20 cities from 7 states last year. This year, the second version of the conference, as Sonia mentioned, had to go virtual, unfortunately, and we would have loved to see you in person. But we have more than 1,650 delegates who registered. That was, I think, a very big number. And delegates were from 16 countries, also from 15 states in India, innumerable from innumerable cities. So there are some announcements I would like to make here before we get into the conference as such. Being an online conference, we have to follow certain things. All the participants on Zoom webinar, please post your questions on the Q&A feature in Zoom. And there are participants on YouTube channel as well. They can post the questions in the chat section. All the participants of the conference will receive an e-certificate for participation after the conference is over. If you get disconnected and cannot join back for some reason, please go to the CS Pathshala YouTube channel, where you can definitely join. The links to the YouTube channel and breakout rooms are available on our CTiS website as well. After the main sessions today are over, at 5 p.m. we will be having 2 breakout rooms. So links for these will be shared with you a little after 4:30, so that you all can come into those rooms at 5 p.m. So both the rooms will have different resource persons. And at 8:30 tonight, we of course have the distinguished speaker, Professor Janet Bing's talk at tonight at 8:30 p.m. Please remember to use the same webinar or YouTube link that you're using, because it's going to be cast on the same link. Before going off, I would like to really thank the organizing committee members who have helped me. Wouldn't have been possible without my co-chairs Shanti Pise, Aditi Karandikar, Anaga Behere, Aarti Halbe, Naveen Kabra, Pradnya Bhaviskar, Soumen Maiti, and Ved Prakash Dubey, who are who have been working with us, and also many volunteers who have helped us with this and are right now manning different tasks which are going on. Of course, who can forget all the teachers know the amount of help that Sonia gives to everyone. So I really would say that that major chunk of the work has been taken up by her. And if this is a success, it would be largely due to her. So with this, I thank you and I pass on the baton to Vipul.
Thank you, Arun. Just give me a moment and I'll start sharing my screen. Hopefully everyone can see my screen and you can hear me as well. So I would like to just first of all welcome all of you, a warm welcome to all the participants. I think as Arun said, it was a pleasant surprise to see so much interest in joining the CTiS conference, a conference for teachers teaching computational thinking in India. So through this presentation, I would just like to provide an update on what all has happened with CS Pathshala since we all last met. Yeah, so I think just for those who have not heard of CS Pathshala before, or those who have joined the conference for the first time, just to give you a highlight, CS Pathshala was set up in about 4 years ago to promote computational thinking in schools. We had a goal, our vision was that every child in India should learn computational thinking by 2030. A few things that we wanted to do was to see how we could influence policy makers on including computational thinking as part of the policy. And you can see that those efforts, the advocacy efforts paying off, and the National Education Policy 2020 now recognizes and recommends teaching of computational thinking. Also, what we wanted to do was to make computing equitable, make it available to all. So what we had done was taken an unplugged approach so that teaches computing without the use of computers. We also created draft curriculum and sample content with the help of volunteers. And we are trying to set up the community where the teachers can communicate with each other, share resources, share experiences, best practices, examples through mediums like CTiS, get speakers to you through webinars. And I'm also happy to talk about CTiS Award, and I'll come to that later. I think one of the things important for us was to see, since this is a new topic, we wanted to see how we could carry out a lot of training programs. And I'm happy to share with you that so far we have been able to reach out to more than 5,400 teachers since 2016. And Cambridge University Press has partnered and they have published books as a derivative of this content. So apart from the 300,000 students who are learning computational thinking using this curriculum, there are 30,000 schools in Tamil Nadu who are learning CT that has been integrated into the math curriculum. And this has been happening for over 2 years now. So the other thing that we have done for the last 2 years is to excite students in computing. Started organizing Bebras India, which is an international computational thinking challenge. Over 3 million students take part in it in more than 50 countries, and 178,000 students participated from India last year in the age groups 8 to 18, and the challenge was offered in 5 languages. So I'm hoping that as more of you get to know about Bebras, you will enroll your students into Bebras, and there's a session on Bebras today where you'll get to know more about it. And so this is again a challenge which is held for free. The other thing that we have done, we understand these are difficult times with a lot of things happening around us, is to ensure that we remain connected with you. And through the webinar series, we have tried to bring to you eminent speakers. We have had Tim Bell, Jonaki Ghosh, Dan Garcia, and tonight we have Janet Wing. And we have a lot of other eminent speakers lined up in this series in the future. I just wanted to share a few pictures from you from how teachers have been implementing this. As I mentioned earlier, this Largely, the approach we follow is largely an unplugged approach, and you can see students working with materials, working with playing logical games on board. Again, this was a big surprise for us, and the ways and means on how Sudoku has been extended by teachers. And I think you can see how they've used flowers and other materials and things to replace numbers with different objects and interest students amongst this. I think in the webinars I've been talking about this, so I'm happy to share that we have now constituted a Teacher Excellence Award for teacher in teaching computational thinking in school, and we'll be announcing this tomorrow. Before I end, I would like to thank all the partners, Cambridge University Press, Arun from Soft Corner. Not only has he put in all the effort with organizing this conference, I think he's helped us in many ways, and also Tata Consultancy Services. So that's all from my side. These are again the partners who have been with us in the journey in the past 4 years, and I'd like to thank them for supporting us for this time. What I would like to do is I would like to request Jayant, who is the president of ACM India, as CS Pathshala is an ACM India initiative, to say a few words.
Am I audible?
Thank you.
Yeah. So thank you, Vipul, and good afternoon to all of you. On behalf of the entire ACM India, which now boasts of 10,000 plus members, I'm really delighted that CTiS 2020 is finally happening. And as was already mentioned, even though we are forced to have it in virtual mode, it has its own advantages in that the reach could be much larger. So CTiS is a recent program of CS Pathshala, which has been a core pedagogy-oriented initiative of ACM India. And I'm extremely happy to see so many teachers in the audience. We have reached close to 500 audience members already. And I think this will grow as we go into the program. So this also fits in well with the new educational policy, which was recently announced by the Government of India. And as Vipul mentioned, in the formulation of this policy, several of the ACM India members have played a key role. So Edgar Dijkstra, the legendary computer scientist, once said that computer science is no more about computers than astronomy is about telescopes. And this spirit is embodied in the conference theme of computational thinking, where the emphasis is on mathematics and science rather than just the use of computers. And we have also seen that the conference has a wide outreach to the grassroots level, as well as the programs in the various schools that Vipul already highlighted. And I really congratulate the program committee here for creating an extremely exciting agenda that is of organic relevance in today's online world. So I would like to again reiterate the strong support of ACM India to these initiatives which are of great pedagogical and societal relevance. And essentially, we can make a transformative impact at the grassroots level for all our children over the entire country. And we all look forward eagerly to the subsequent conference proceedings. So thank you all for this organizing this wonderful event. And I'll now hand it over to the program committee co-chair, Professor Venkatesh Raman, who incidentally is also the secretary of the ACM India Council. Over to you, Venkatesh.
Thank you, Jayant, and good afternoon, everyone. And again, a warm welcome. As Jayant mentioned, I have been in the ACM Council for the last, this is my 5th year. And every year, I, along with other council members, used to wonder in great surprise about the reports Vipul used to tell us about the CS Pathshala, the kind of numbers that have happened, reached hundreds of thousands of students, thousands of schools, training, and hundreds of volunteers and teachers. So last year was my first year to see in flesh and blood the foot soldiers, the teachers and the volunteers. When I went to Vijayawada for a teacher training camp for Andhra Pradesh Social Welfare Scheme Board schools. And also again, through CTiS 2019 and through all these abstracts. So one thing which is constantly visible in all the abstracts and in the teachers is the great joy and enthusiasm and the energy displayed by this, everyone implementing CS Pathshala. That tells me that we must have done, we must be doing something right. So I'm actually proud to be part of this journey along with you. And we were hoping to see you all this year, but at least it's better than nothing, that at least we are having this virtual event. And I just want to reel out some numbers from the papers. Can you see the screen?
Yes.
Is the screen visible? Yeah, okay. So last year we received about 55 abstracts across 7 states, and we shortlisted 9 of them. And the criteria for selection largely was that something individual experience, some novelty of examples, some individual impact, and so on. And we passed these guidelines to the program committee members, and each submission was reviewed by 2 committee members. And based on their review, and then after discussions, we shortlisted them. This year, to increase the quality and quantity, we actually had pre-selection meetings at AP Social Welfare Schools and also at Mege Group of Schools at Nagpur. So AP Welfare Schools had their district level selections. And at the end of all this, we selected 14 abstracts out of this 307 abstracts received through these pre-selection meetings as well as later. These abstracts, as you will see in the session, are categorized into the themes of CS Pathshala: systematic counting, information representation, physical computing, Scratch programming. And there are some schools who have nicely integrated computational thinking into their maths curriculum, so we'll have a session on that. And there are also lots of challenges in implementing computational thinking, given that it is not a compulsory subject. So we will have the session discussing about the challenges and how the schools managed to implement and even came up with the assessment for computational thinking. Apart from these paper presentations, we have a keynote by Sridhar Iyer of IIT Bombay and Janet Wing, Jake Baskin of Computer Science Teachers Association of North America. And TCS has a new program for improving design thinking. We will have a session on that. We will have a session on Bebras experience. People already mentioned about it. And in addition, one thing we miss out in a virtual conference is the lack of possibility to socialize. So just to recreate a little bit of it, we have breakout rooms at the end of at 5 o'clock for whoever wants to hang around. And Sonia has promised some nice snacks and coffee for these breakout rooms. And so before I conclude, I would like to thank my program committee who have not only helped us in shortlisting the abstracts, but also played a big role in mentoring the teachers of their presentations today. So Mansi, Meenakshi, Mridula, Nikhil, Paritosh, Pratiksha, Premlata, Ritambra, Vandana, and Veda. So, and we thank you all. And again, a warm welcome. And with this, I would pass it to Venkatesh of Tata Consultancy Services to introduce the first keynote talk and to chair the session. Over to you, Venki.
Yeah, hi. Thanks, Venkatesh. It's a pleasure to introduce our first keynote speaker, Sridhar Iyer. He's a professor at IIT Bombay and teaches in the computer science department. Okay. He is very passionate about education, especially technology in education, and therefore very appropriate for Computational in Thinking School conference. He heads a program on educational technology at IIT Bombay. He has also he's one of the leading publishers from India in the area of computer science education, and he's published widely in many international conferences. Among the various projects he leads is one called Telots, which is an attempt at learning of thinking skills. So it's not just in computer science, but in general, how do people learn thinking skills, how to learn thinking skills. That's what it is an attempt at. He had got into CS education in schools much before CS Pathshala in the form of Computer Masti, a collection of books that he has published for teaching computer science, computers from standards 1 to 8. And these can be downloaded from, from the site because it's available for free. His interest in education can also be seen from articles he's written for Jantar Mantar, which is a children's science education magazine. So you can read these articles also when he's not involved in computer science education. He enjoys himself by trekking, playing volleyball, and he has also played bridge. I think that he plays bridge is a good enough reason to invite him for a talk for any conference. And with this, I'll hand it over to Sridhar Iyer. Over to you, Sridhar.
Thank you very much, Venki, for that introduction. Thanks a lot to Venkatesh Raman and the other organizing committee for inviting me. So all of this, what Venki has said, is not there on my bio. It so happens that we know each other from earlier, and so he is actually put in a lot of additional stuff. Anyway, thank you very much for that introduction, Venki. And with that, let me get started. I'll just quickly share my screen. Okay, so this talk is about computational thinking, education, and research. And since most of you are aware of the CS Pathshala work, I'm not going to touch upon that work at all in this talk. I'm going to try to give you some different examples. To begin with, let me quickly give an introduction to this department, since many of you may not have heard of education technology as a department. So before EdTech became so popular and all that, we started this program a decade ago. This is actually our decade of EdTech at IIT Bombay that we are celebrating. And currently we have 5 core faculty, several associated faculty from other departments, and postdocs, and 25 students are there, and about 12 PhDs have graduated. And we have also admitted our second MTech batch. So we have had one batch of MTech which is ongoing, and the second batch has joined us in virtual mode, and hopefully by January they'll be here physically. If you want to know more about what all we do, you can actually just Google Education Technology IIT Bombay. It will take you to our website, and there you can see all the research areas and different themes that we work on. What are the MOOCs that we have created? We've done a lot of teacher training MOOCs. Maybe some of you have also participated in them in how to use education technologies in the classroom and how to do CS teaching in the classroom and so on. Okay, so with that, let me do a quick activity. What I would like you to do is get an idea of what is your idea of computational thinking. So if you could open a new tab on your browser and go to menti.com and type in this code, you can give your answer through that interface. I'll just put it in the chat window also. So you go to menti.com and put in this code 9542061, and we'll just get a quick idea of what do people think. Okay, let me also share the screen so that you can also see how the answers are evolving. So we are seeing answers like logic, logical thinking, system, computer science, problem solving, coding, programming, peace. Okay, problem solving, 21st century skills, reasoning. Okay, sequential learning. Algorithm, critical thinking. Okay, maths, artificial intelligence, stepwise problem solving, decomposition. Okay. Learning of thinking skills, abstraction, technology, think like computer. Okay. Quantification. Okay, there are some interesting answers also are cropping up. Okay, we have about 150 responses, and it's very heartening to note that the main responses which are standing out so far are problem solving, critical thinking, logical thinking, okay, and reasoning, okay, rather than programming. You know, I was a little afraid that programming would turn out to be kind of the winner, and then we would have to go all the way from saying that it's not just about programming. Anyway, so it's great to see these responses. Let me come back to the presentation. So this actually makes my job a little easier in terms of this talk, because most of you seem to already have a background of what I'm going to talk about. Okay, so if we look at the what, why, and how of computational thinking, there are some aspects of it. Let me just go into it one by one after this definition. Okay, so computational thinking refers to the thought processes involved in formulating problems and their solutions, so that the solutions are represented in a form that can be effectively carried out by an information processing agent. So this is the classical definition, most often cited, and we'll be hearing Professor Janet Wing herself later on today. So one reference that I can provide is this book called Computational Thinking Education, which is edited by Professor Su Chong Kong of Hong Kong University and Professor Harold Abelson of MIT. And there's a chapter in it on computational thinking in India, which is been written by me on the Computer work. So most of this talk is based on that chapter. And the definition that we will be using for this talk is what is called the operational definition of computational thinking, given by ISTE and CSTA. It basically is a little broader than programming, and it includes formulating problems in a way that enables us to use a computer to help to solve them, automating solutions through algorithmic thinking, which is basically a series of ordered steps, and generalizing and transferring this problem solving process to a wide variety of problems. Okay, so now if we ask the question, why bother about teaching learning of CT? I'm sure a lot of you have already don't need to be told about this. I mean, we are all agreed on this, but nevertheless, if we are talking to colleagues who are not so familiar with it, here are some points. Okay, so one point is that we need to nurture the next generation to become creative problem solvers. And CT helps learners to formulate and solve problems in the digital world. So there is a need for integration of CT in K-12 education, which there are lots of references, and it's very heartening to see the amount of work that is being done by CTiS Pathshala on this. Okay, in the worst case, if none of these arguments work, there is also the fear of missing out, right? The FOMO effect. So many countries have already started implementing CT in schools in a big way, and so at the very least, we should not be left behind. So that's the the most common denominator answer. Okay, so I'll give you a few examples. So this is from the set of books that Venki had mentioned called Computer Masti. So my own exercise in this direction started in 2007. So when my son was in the first standard, and I looked at the computer books at that time, and I decided that I didn't want him learning computers from those books, which basically had screenshots of Microsoft Word and questions of the sort, how many colors are there in the palette and so on. So it was a longish effort, and it took us a while to write the curriculum, and then we also wrote the teacher handbooks, and then we realized that it's not enough to only write the teacher handbooks, and went on to write the textbooks. So after writing the textbooks, we discovered that it's not enough to just write the textbooks. It's necessary to do the teacher training. So at some point, I started a company in 2009 for taking this out to schools. And then in 2016, this was acquired by another company called Next Education. And today, this Computer Masti is a product of Next Education. However, these books are all released in Creative Commons, and they can be freely downloaded from my website. So if you Google Computer Masti, it will just directly take you to the website from where you can download these books and use them freely. So this would make a good complement to the content that you get from CS Pathshala. Okay, so basically it addresses aspects of problem solving such as algorithmic thinking, logical reasoning. It addresses aspects of logical data handling. No, that was not such a common term that came up in the word cloud, and also talks about multiple data representation. So these two are not so commonly thought of as part of computational thinking, but actually they are. Okay, so here's an example. So it's a very common example, and which all of you will be familiar with, which is basically stepwise thinking. And the way it works in Computer Masti is that there is this character called Moz, who is a facilitator. So this Moz is a facilitator, and there are two children, Jyoti and Tejas, who are actually trying to learn it. And basically through that, they learn that any activity has a sequence of steps, and it's useful if we follow a problem decomposition approach of first listing the main steps, and then for each main step we list the detailed steps. So it will be surprising to see for how long through one's career this simple idea actually holds. So I do a very similar activity even in my MTech class, and the number of people who dive into details before they have thought through the main steps is phenomenal. Okay, so it cannot be underemphasized that stepwise thinking, the ideas of problem decomposition, the ideas that we build in as function calls or subroutines and so on, are very important ideas that are broadly applicable everywhere. Okay, so to give you a quick feel of how the content evolves, it starts up in grade 3 of breaking up a non-computer activity. Okay, let me see if I can use the pointer. Okay, so it starts in grade 3 where we say, okay, we are breaking up a non-computer based activity into steps, and then it kind of extends in grade 4 where we are talking about there are some constraints now which are beginning to apply. In grade 5 they have to kind of identify known and unknown information and go and gather information. In grade 6 they learn how to do pros and cons analysis, how to choose between multiple solutions, how to apply reasoning, decision making, and so on. And in 7 onwards they solve increasingly complex problems. So this is basically the way the curriculum has been structured, and I won't go into more details about that here. Okay, here's another example of applying stepwise thinking and programming. So we use Scratch in the book as the programming language from grades 3 to 6, and then we use BASIC after that. So so yeah, here's a very elementary example that Shilpa has to go from here to there. So there's a notion of integrating with something that the children are already familiar with. So they're already familiar with it, and so there is a corresponding Scratch program which they write, which gets the idea of what is the connection between everyday activities and a computational activity which can be done using a programming language. Okay, so having said that, it's time for another break. So all these orange or whatever color slide that you're seeing are slides when I take a break and you do some work. Okay, so this activity is basically for you to express your opinion. So you can do this using the chat window itself. We don't want to go anywhere else. And you can actually turn your chat to saying all attendees. And the question is basically, is it just another buzzword for programming? because these CS guys are like that, right? I mean, we always like to kind of push the ideas and pretend as though these ideas didn't exist earlier. So is it just another buzzword for programming? So do you agree, yes or no, is the first thing. And why I have not set it up as a poll is that, I would like you to also write your reason in the chat window. So I'm going to come out of this full screen mode and go off to the chat window. Okay. Okay, there are a whole bunch of no's, but we can do CT without knowing any programming language. I'm just reading quickly. I'll read out a few answers that come. Predominantly, the answers are no. CT is a way of life, somebody is saying. We do it every day. It's a skill which teaches us to think critically. Step-by-step approach can be easy to write programs. CT was always there. If math is taught well, many of these objectives will be achieved. Yes. Okay, now it's moving too fast for me to read, but I'll still try to read a few. Okay, programming has additional implementation aspects. It's a subset. Programming is a subset of CT, yes. Okay, it's not another buzzword because it involves building algorithms. Okay. It involves step-by-step inculcation into developing thinking skills. Okay. It's not dependent on implementation details. Okay, I think most of you are kind of leaning in the same direction of saying that it's not entirely a new buzzword. There are very few yeses for yes, it's a buzzword. Okay, it's not completely depending on programs or computers. Okay, so let me go back to the presentation. Thank you for your responses. So a lot of people have responded. Thanks for that. And let me go back to the presentation and see. Okay, so here are some typical audience responses. So this is a talk that I had given last year at T4E, and so some people kind of think that CT is the same as programming because everyone talks about it in the context of programming, or because it is step by step and so on. But like most of you have said, it is not the same as programming because these ideas have been explored in other domains as well. And it's mostly about thinking, not about programming. And like many of you have also observed, programming is a subset, or see, one aspect of CT is programming. Okay, so thank you for your responses. And let me just summarize by saying that learning of computational thinking is not the same as learning of programming, although learning to program can help in the learning of CT. Okay, so CT is a superset of skills, of which programming is one skill. And some of the other skills are logically organizing and analyzing data, representing data through abstractions such as models and simulations, identifying, analyzing, and implementing solutions, right? Doing some pros and cons analysis, doing some optimization. So these are all other skills which are part of what we call as the CT framework. So here is one view of the CT framework. So there are multiple frameworks available. And since I thought, let me also introduce some research aspects. So this is one popularly used framework for categorizing different aspects of computational thinking. Okay, so it categorizes into concepts, practices, and perspectives. Okay, so in concepts, what we see is basically these are your typical programming constructs. Okay, so computational concepts that learners develop in programming. So often people stop here, and that's why they conflate CT with programming. But then we see that there are also CT practices where we have things like problem formulation, and then while there is also algorithmic thinking, while there is also iteration and testing and debugging, which are all found in programming, these are all often done in non-programming settings also. And then finally, we have the notion of CT perspectives, so where they are able to express their ideas using computational concepts. Okay, so that is basically programming, empowerment, and perspectives of expressing. So this is one framework. So those of you who want to go deeper into research in CT, this is a good place to start by looking at this framework and getting a hang of what exactly falls in CT and what does not. Okay, so here's another quick question. Is CT only for computer science topics? Okay, so in some audiences, I take a couple of minutes to discuss this question, but for this audience, we don't need that because most of you have already answered that it's not, and that's correct. That CT is not just for CS topics or for CS students. It is much broader and it can be found in several disciplines. Like this reference that I have quoted here has a list of 20 disciplines in which there are research papers on CT. Okay, so here are some more examples again from Computer Masti for CT in a non-programming setting. So the first example is about setting up a home aquarium, where you divide. This is in grade 5, where you divide what you know, what you don't know, and then you go on to gather information, identify constraints, what is the budget, what is the type of the fish that can be kept, and so on, and then use logical thinking to identify choices. So over the years, this project has been implemented in a lot of schools, and a lot of children have said that after going through this such a curriculum, they find that they are able to use these ideas in projects in their other subjects also. Okay, so then there is also the idea of applying CT when we create presentations, right? So often, many people have the idea that if I have to create a presentation, I have to use a lot of fonts and I have to use a lot of colors and I have to use some lot of animation. Actually, that's not true. So the idea is about communicating your own ideas. And again, it's best done if we approach it systematically. So the same idea of deciding what is it that we want to talk about and then writing some details about each point. So that's again a basic computational thinking being applied to creating presentations. So so like the slide says, it's about 3 stages, where you plan and then you execute, and then finally you add some visual effects in order to make it sticky for the audience. Okay, so then let me give a few more examples. CT applied in STEM. STEM stands for science, technology, engineering, mathematics. And nowadays it's been expanded to STEAM, where A stands for arts. So this is a work by Professor Gautam Biswas at Vanderbilt University. This is called C2 STEM. So the idea here is the learning of the domain, right? Physics or something, by attempting to model. So students learn by building computational models of the science process and then applying the models to problem solving tasks. So it's a very interesting approach of going back and forth between the science domain and the computational domain, thereby strengthening both the domains. Okay, and then there is also CT, which we can find in literature. Okay, so here is somebody who was Frank Moretti of Stanford, who has applied CT to Hamlet. And the basic idea here was to actually just represent everything as a graph, all the people as a graph, and there's a link between two people if there has been a link. So analyzing these network diagrams where the characters are nodes and two characters are joined if they have interacted. Okay, so it turns out that there are only two people who managed to survive this region of death, and somehow they are able to kind of say that this indicates who was the culprit and so on. Okay, then there is computational thinking applied in e-textiles, where there is notion of learning by making. This is by Professor Yasmin Kafai of Penn State University. So students devise their own projects, they sew with a conductive thread and write computer programs for microprocessors. Okay, so the approach is again here to explore computer science by doing non-CS type of activities. So we also have a slightly different project at IIT Bombay, which is in the realm of tinkering. So tinkering, as some of you may know, it's basically, it's the basis for the skill of making, or the skill of identifying what we can do and how to do with things and so on. So those of you who have these Atal tinkering labs in your schools, may be able to identify with this a little better. So what this is one of our students, Ashutosh Raina. What he has done is he's come up with a tinkering kit and a corresponding pedagogy of letting students explore. Of letting students exploring the resource affordances, so that students can see what they can do and what they can do with it, and then using it to solve a simple problem which is given, and then eventually evolving it to solve bigger problems. So this pedagogy is called Explore, Solve, Evolve, and through that students are able to solve. So we have used it with school students as well as for college students with appropriately different set of problems in order to nurture the skill of tinkering. So this is another example that we can take a look at. Okay, so again, to just give you a quick break. So there is a lot of CT work. I mean, the CT is not at all new. So there's a lot of work in India, and the most ancient one is apparently from Chandas Sastra. So Professor K. Ramasubramaniam from our department of HSS is actually a scholar and expert in all this. And basically, when I asked him, saying, okay, can you give me an example of CT? This is the sutra that he gave me. It goes as Dvirdyunam Tadantanam. And let me see if I can play his video, his audio. Okay, so this is a 2-minute audio. So I'll just play maybe a minute of it.
Laghu, like in the word Rama, and both can be Guru, like we have Krishnam. An interesting question has been posed by Pinkalacharya in his Chandas Shastra. Given n syllables,
so
he asked this question.
Check whether it's happening. You can't hear it. People are saying no. Okay, so let me get out of the.
We can hear it.
We could hear
okay.
Sridhar.
Okay, there were a bunch of people who said no, so I was a little
very clearly.
All right. Okay, let me go on. Okay, let me just back it a bit. Yeah, we'll play it for a minute.
An interesting question has been posed by Pinkalacharya in his Chandas Shastra. Given n syllables, he asked this question: how many possible patterns that can be generated up to n syllables? So this is basically a mathematical problem wherein we need to find sum of sums. The solution to this has been presented in the 8th chapter of his text Chandas Shastra, which goes as Dvirdvyunam Tadantanam. Tadantanam refers to the number of patterns that can be generated with n syllables. That has to be multiplied by 2, Dvihi. And then he says Dvyunam, which means 2 has to be subtracted from them. So this in mathematical parlance amounts to 2 to the n plus 1 minus 2. As we can see, so this is basically the sum of a geometric series having n terms, with the first term being 2 and the common ratio being 2.
Okay, so that was Professor K. Ramasubramaniam from our department of HSS establishing that CT has been there in ancient India. And in more recent times, okay, 1 second. Okay, and in more recent times, what we have are the work that I have been talking about. On maybe I have to stop sharing and start again. Okay. I'm not going to go into this. Okay, some reason this is frozen. Try to. Okay, this is the usual PowerPoint related issue has happened. It has frozen for some reason. Okay, let me come back to it again and hopefully get out of it in some way. All right, okay. All right. So, so the CT work in India is basically, as you know, I just talked about Computer Masti, and then Venki also mentioned this TLOTS project, which is what we are trying to do at the higher education level. I'll just give you a couple of examples in a moment. And then there is, of course, CS Pathshala. And then if you look at Amrita University, they're also doing some work in this area, which is about developing tinkering mindset in school children. So I'm sure there is other work which I'm not aware of. So in case you are among those who are doing some work in this area and I'm mislisting you, do send me an email so that I can include it in the next iteration. Okay, so again, now if we pause to reflect, is CT just another buzzword for problem solving? So basically what we are doing is we are looking at the two extremes. At one extreme, we ask the question, is CT just another buzzword for programming? And we decided that no, it's more than programming. So now we are saying that we are looking at the other extreme to see, is it just another buzzword for problem solving which has been around for millennia? So it turns out here that there's no clear answer yet. So the debate is still ongoing. So different proponents of CT have different pet positions on this. For example, Mark Gusdale subscribes to this minimalistic definition, which basically says that, what is it that we have to learn in order to communicate our tasks with the computer? So the minimal part is what is CT, everything else is problem solving. Okay, and then there is Weintraub, who talks about the empirical definition, which basically talks about the computational practices of actual scientists and engineers who use computing. So what are these computational practices? Like one of them could be iteration, like you do an experiment and then you change one value and then you do the same experiment again, and then you plot a graph, and or you do something, you do a problem decomposition, you split a problem into sub problems. So these are computational practices which actual scientists and engineers use. So the empirical definition includes these practices. And then there is also the debate or the discussion on the implications of defining CT in a restricted manner versus a wider, more open definition. Okay, so it's not like everybody has agreed upon what is CT. Okay, so here's my personal take on this. So the debate on is CT equal to problem solving has not yet converged, and I'm inclined to take this stance. Okay, so CT is not just programming. So it is a bunch of programming concepts. So from the framework that we saw, Brennan-Resnick framework that we saw earlier, we take some CT concepts and some CT practices. That's what we are calling as programming practices. And then we also take some disciplinary practices. Okay, so add some practices of actual scientists and engineers. I'll come to an example in a moment. So these together comprise what we call as what we could call as computational thinking, which is now broadly applicable to a large number of engineering fields. Okay, so let me give you an example. So this is an example of CT in higher education, or also an example of what we mean by disciplinary practice. So let's say troubleshooting. So if you want to do troubleshooting, whether you're troubleshooting your home network, or whether you're troubleshooting why a light bulb is not glowing, or whether you're troubleshooting a car, so irrespective of what you're trying to troubleshoot, the stages that you go through are pretty much very similar. Okay, it's a process which ranges from identification of the problem and implementing the action to fix them. So it involves understanding the problem, it involves generating a hypothesis, and then coming up with a priority of which hypothesis to test, designing these tests and then interpreting the results and then iterating on that process. So the claim here is, so this is work being done by one of my PhD students, Kavya, and the claim here is that working through these troubleshooting stages systematically is an application of CT. And so getting students to do these troubleshooting activities with explicit reflection can lead to the inculcation of CT. Similarly, I'll give you one more example and I'll stop. So this example is of divergent and convergent thinking in design. So here again, what we need to see is software design is a process which is ranging from requirements analysis to detailed design to testing. And if we look at conceptual design, most of us will agree that it involves first expanding the problem space by considering multiple perspectives, and then you are reducing the problem into sub problems. Then you generate multiple alternative solutions and then choose what is a good fit or a best fit type of a solution for the given constraints. So here again, the point is, when we make students go through this process of design, irrespective of whether it is programming or whether it is designing some product, they learn CT. So again, working through these stages systematically is an application of CT. Okay, so teaching learning of design includes teaching learning of some CT practices. Okay, so this is nearly my last slide. So since I had said that I will also talk about some research opportunities in computational thinking, so it's actually fairly broad and open right now. And one easy way of getting into it is to design and evaluate interventions to develop CT in your students. Okay, so basically it involves creating some intervention, which is learning activities that involve use of CT in various domains, and then show explicit mapping between your design and the learner's development. So because I did this, they developed that CT. So you have to fix the definitions and then show the mapping between that, and then do evaluation to explicitly show. By evaluation, we means we have to carry out some tests and some interviews and so on to show that CT has been developed. So it would be great if you can, if you take this up and submit a paper, not just to CTiS, but also, there are these other conferences which we run in India. One is called T4E, which is Technology for Education. This is an IEEE conference. And the other one is Compute, which you may be familiar with already, which is ACM's conference on computing. And for help with planning studies, etc., again, if you go to our departmental webpage, there are a lot of resources that we have put up there. Okay, so with that, let me come to the close. So what's the takeaway? The key point I would like to make here is that CT is not automatically acquired while learning content. Okay, it's not like, okay, I simply learn and automatically I have learned this. I mean, we have seen it time and again. MTech students are not able to apply it when they come to a MTech class on, let's say, whatever topic, it doesn't matter. So learning of CT needs explicit training, and the sooner we start, the better. The second point is, one way to train for computational thinking is through programming concepts and practices. But transferring that to a non-programming context does not happen automatically. So nothing happens automatically. No, CT is not learned automatically, nor is it transferred automatically. Both of these need explicit attention and explicit training. So if you want students to be able to apply CT in a non-computational scenario, what we have to do is we have to train them. We have to give them multiple such examples, like planning a picnic or like, doing a project, setting up an aquarium, etc., etc. Bring out what is the CT that is involved in doing that, and show them explicitly how the same steps are occurring again and again in different projects. And that's when it becomes internalized. So that's the basic point. And I'm sure as teachers, you've already also seen this in your own classes. Okay, there are a lot of things that I've not talked about. Here are a bunch of references to the points that I made. And there are a lot of things that I've not talked about, which are tools, assessment, non-formal learning, etc. And this presentation itself is available from my website. So if you just Google Sridhar Iyer IIT Bombay, you can go download this presentation. You are also free to use material from this presentation in your own talks. With that, thank you very much. And back to you, Venkatesh. It's 3 o'clock.
Yeah. Thanks a lot, Sridhar. It was a very interesting talk, and I'm sure everyone enjoyed it. And there are a few questions for you.
Okay. Will you be reading them out?
Yeah, I'm reading them out.
Okay.
So the first one is, yes, teachers do believe that computational thinking should be taught, and it's not just programming. But when they try to teach in a class, let's say flowchart design, algorithm design, or anything, students want to directly dive into Scratch programming, and even parents prefer to get that done. So how would you address this problem?
So this is a very important point, because even when we wrote Computer Masti, so we had an explicit chapter called Stepwise Thinking, which came before the Scratch chapter, and which had nothing to do with computers. So it was all about, move around in here, go from here to there, and so on. And in the initial few years, the feedback that I got from schools is, why is this chapter here? Remove this chapter from the book. It makes no sense to have a chapter which has no programming in it. So it is a matter of education, and while students get to it by let them do the Scratch programming, and as long as we keep showing them the similarity. See, what has to be stressed is what is the same thing. This is nothing but what you have done before. As long as we keep showing them that, oh, you wrote a Scratch program for making the sprite move in a maze. See, when you do this, when you're taking your car and you're navigating, Google Maps is doing the same thing. So when we show some things like that, that's when they realize that there is an abstract nature to it, and they are able to acquire it. For parents and teachers, we have to keep on telling them that, look, it is broadly applicable. Yeah.
Thanks, Sridhar. Another question is, how can CT be taught while teaching economics to school students, or commerce or accountancy to school students?
Oh, definitely. See, today though, there is a lot of emphasis on data and data analytics and all of that. So that is definitely one component. So you can start with simple graphing, where it doesn't matter. See, you can expand the definition of CT a little bit to just say systematic thinking also. And yeah, so you could start with, let's say, I don't know the domain very well, so I'm trying to come up with an example on the fly. So you could start with some scenario in which they have to do some inventory analysis, and maybe some planning of how much stock to maintain depending upon supply and demand. And there you can actually bring out, okay, so look, this is what is happening behind the scenes. When a shopkeeper is doing that, the shopkeeper was doing it intuitively, and today there are a lot of algorithms which are actually helping the Amazons and the Walmarts to figure these inventory out. So there are ways in which we can inculcate it, and even if we don't have to struggle to find them. We can take the simplest one. As long as your students are thinking more and more systematically, I think you're doing a good job. It doesn't matter whether we call it CT or mathematics or whatever else.
Yeah, thanks. What are your thoughts on training, mentoring, or grooming our school children on these concepts, keeping in mind the time available to them?
Yeah, so the time is a big issue. So see, many of these things get relegated to after school activities. So when we had actually come up with Computer Masti, CSIT was not a core subject at all. So it had to be clubbed with the other after school activities or the extracurricular activities. So at the very least, let it be that, instead of eliminating it altogether. And I think slowly it will come into mainstream. More and more people are realizing its need. So what is a good way of doing that is this idea called thematic integration. So if you look at the Computer Masti web page that I talked about, so the curriculum document actually says that how can we do this thematic integration? What do we mean by thematic integration? Is basically when I am talking about geography, how do I also use that to teach some other CT concepts? So if we can write some content, supplementary content to the geography textbook, which actually says that, okay, or maybe use a AR marker nowadays, just put a sticker in the textbook where we can say that, look, okay, if you are more interested in the CT aspect of this concept, you can just hold your phone over it and go look at it. So those are ways in which we'll have to bring it in, and then eventually it will become mainstream.
Yeah, great. So there is, of course, a request for links from where they can download your books, your various content. And
so, yeah, so all of this is basically you just have to Google Sridhar Iyer IIT Bombay. Let me see if I can just quickly show you those web pages that I'm talking. Okay. Okay, let me just share my browser. Okay, so this was a Mentimeter link. This will also be useful to kind of keep. So you just say, okay. So if you Google Sridhar Iyer IIT Bombay, it will take you to this page. This is my basic web page. And if you click on Computer Masti here, it will take you to the first link up here that you see is the curriculum document. It's basically a 60-page document which defines, what should be taught, how it should be taught, and so on. And then these are the links for downloading those individual books. Okay. And similarly, if you Google Educational Technology IIT Bombay, it will take you to this page, which is our departmental web page. And here, if you look at resources, again, you will find several handbooks that we have created for how to do research in educational technology, and you can use these resources in your own research. Okay.
Yeah. Another interesting question: how different is computational thinking from analytical skills?
How different is computational things? So again, see, these are all, there is a lot of overlap between these areas. Okay, so, and each generation comes up with different terminology. Okay, and it's sort of, sometimes it can be considered as old wine in new bottles. Okay, now it depends upon what exactly you mean by analytical thinking. Where do you draw the boundary? So any definition can be expanded to include more and more things, and thereby encompass all of problem solving. So that's why I asked that question very specifically. Is it all the way up to problem solving? Where does CT stop and where does some other type of problem solving begin? So that is a question that each of us have to answer for ourselves. And what is important is to be very precise about the definitions that we are using in order to come to that call. So if you're using definition A for CT and definition B for analytical thinking, you may come to the conclusion that CT and analytical thinking are very different. On the other hand, if you're using a definition X for CT and some other definition Y for analytical thinking, you may come to the conclusion that they are the same thing.
Yeah.
Okay.
So if CT is to be part and parcel of teaching, mainly for secondary and higher secondary grades, what would your approach be to train teachers to ingrain CT in their teaching?
Yeah.
So I assume they are referring to other subjects as well.
Yeah. So this is a problem that we have been working on for a while, actually. So, and it's not an easy problem, not because of teacher competence. So often people, the first thing that people jump on is saying, oh, teachers don't know. Actually, that's not the problem. The problem is there is no room in the timetable. So it's the packedness of the timetable, which is, so if we go towards a more integrated curriculum, where two teachers are somehow collaborating, it's not, I mean, it happens in some schools which can control their own syllabus and their own timetable. Okay, but for other teachers, what I would say is that it's not like all of us know some CT or the other. It doesn't matter whether you heard the term CT or whether you have not heard the term CT. When you go to, let's say, whatever some website to book your ticket, etc., you're actually applying CT in some way. So as long as teachers are aware that, look, this is going to be an important skill for our students going forward, and let me try to inculcate this in my subject to the best way I can, then I think teachers can themselves do it. It's not like the teachers don't know CT and they have to be taught CT first and so on. Everybody knows it. It's a matter of making it more explicit and making it both for the teachers as well as for the students. Okay.
Yes. I think we have time for a couple more questions.
Sure.
So there is this question which many teachers will be facing if they're starting in standard 5 and the children haven't learned any computational thinking earlier, and so therefore they don't have a basic founding. how would you advise them to go about teaching CT?
Okay. So one of the things that we have to do, okay, so firstly, when we started writing Computer Masti, I asked this question, when should it be introduced? Okay, and then decided that, you know, even by looking at psychology, etc., is that around the age of 8 is actually the best, is a good time to introduce these topics such as systematic thinking and so on, because that's when the child's you know, that part of the brain starts developing, etc. So there is no point in introducing these ideas all the way in first standard. So what we settled for was to introduce them in third standard. And then it turns out that a lot of schools and governments have said that let's introduce it only from fifth standard upwards. So what happens? So one of the things that we can do is, you know, you can think about having, for the first year of introduction, you can have some kind of a bridging. So if you take a fifth standard child, for example, that child would have also gone to a mall and you know, done some activities. So there are a lot of real life experiences which any child up to fifth standard would have reached, which can be used to bring out the CT aspect of those experiences. So that's where we'll have to start. So we'll have to write some, you know, maybe a short bridge curriculum, which will actually bridge what you hope that they would have already encountered to where the curriculum is starting in fifth standard.
Yeah.
Taking a third standard curriculum and deploying it in fifth standard is a waste of time. And I think that's what the question actually is.
Right. You're right. Yeah. So thanks, Sridhar, once again for a very entertaining talk and a lot of answers. There are still many more questions. Unfortunately, we have run out of time. To all those who have asked those questions, we will try and capture those questions and get back to you with answers. Thank you all those who asked questions. Thank you very much for asking these questions. Many of them were very interesting questions. And I will now hand it over to Shanti Pise to carry on with the program. Thanks once again, Sridhar. Thanks a lot.
Sure, thank you. And just for information, the background that you see is IIT Bombay. I'm sure Venki knows that.
Yeah, thank you, Sridhar. It was really nice, and thank you, Venkatesh, for being the chair and interacting with Sridhar. It was truly enriching experience for all of us, especially what is CT and how CT can be transformed into classroom. So it was really nice. Thank you so much. And now we are here we all are waiting for the teachers' presentations. So I would request now the session chair is Meenakshi. I hope Meenakshi is there as a panelist now. And yes, so Meenakshi is here. She is going to introduce the presenters for now, and then we will have their presentations. So over to you, Meenakshi.
Yeah, hello. Thank you very much, Shanti. I hope all of you can hear me. Thank you, Professor Sridhar, for an excellent talk. We hope to continue the day with such excellent talks in the session. So this is the first session of abstract presentations. So the topic of the session is CT and mathematics. We have 3 very interesting talks that have been recorded and will be played. And I hope all the 3 teachers are there. So the first talk is by Swati, with a joint work with teacher Kalyani. They are teachers from SOS school in Athre Layout in Nagpur. And following that, we would have a talk by Swati once again, another teacher, along with Rohini and Shilpa, who are from another SOS school, this time in Amaravati. And the third talk is by Ankita, who is from SES Gurukul, Pune. So over to Aarti for playing the videos.
Yeah,
teachers, please do stay on.
Yeah. So teachers, we will request you to start your videos. And now here we go. Just sorry. I'm really sorry. There is some technical. Some
Shanti,
technical
let me
error
try.
is. No, I'm just trying now.
Okay.
Just a minute, yeah. Yes, this is the one. Yeah.
The audio is not coming through. Shanti, instead of sharing the application, can you share the entire screen? Maybe that is one of the things.
You are not able to hear the audio?
No.
No, Shanti, audio is not coming.
शेयरिंग ऑप्शन में यहाँ पे जाओ मोर में
Just a
शेयर कंप्यूटर ऑडियो
शेयर कंप्यूटर ऑडियो करो, हाँ हो जाएगा.
Actually, I'm sharing the computer audio. Here it is coming.
Yeah, try sharing the entire screen instead of one application.
Okay, I'll do that.
Yeah, remove the share and then again share the entire screen.
Yes, I will do. I'll stop this share and I'll share the entire screen. I'm really sorry for this. We actually tried, and it was. Now I hope you can. Now
it's still loading, Shanti. I think should come soon.
Hello, can you hear now?
No, it's still loading.
It's still loading. We can't see the video still.
Oh, yeah, just a minute. I'll try. Actually, it was working very fine. I'll try one more time again.
वर्तते.
Now can you hear?
यथा शिखा मयूराणां नागानां मणयः तद् वेदांगशास्त्राणां गणितं मूर्ध्नि. Mathematics is the queen of all sciences, and computational thinking is the heart of this queen. Good afternoon, all. I, Mrs. Kalyani Morod, and my colleague, Mrs. Swati Patil, focusing how mathematics learning is enjoyable forever with computational thinking. Can computational thinking help to solve math problems? When it comes to complex mathematical concepts, can computational thinking help to understand these concepts? Let us see how are children developing problem-solving through computational thinking. Any complex problem in any walk of life can be solved by systematic approach of decomposition. CS Pathshala lessons have enriched the student learning process and the teacher's development. Meghe Group believes in innovations, and School of Scholars is institution which nurture every child to become scholar in future. It established in 1987. An integration with math and computer started since 2018. Children learn basic counting in their primary classes. The CS Pathshala lessons on counting reinforce counting techniques through systematic approach. Another lesson on combination of clothes beautifully explain the concept of combination through daily life example. The lesson on arranging the different colored bricks help children to count the number of combination under multiple conditions. So, counting combinations with number was easier for them. They were asked to solve this question. You are given 3 digits, 7, 2 and 9. How many 3-digit number can be formed without repeating any of them? Children followed the systematic approach, and since the condition is the digits cannot be repeated, they started with any of the given digits and they put it in hundreds place. Then they arrange remaining digits in tens place and ones place. This was their first combination. Another combination was found just by interchanging the ones place digit with tens place digit in first combination. And when these steps were repeated with the remaining two digits in hundreds place, they got all 6 combinations with given condition. Another question was, a cycle stand vendor gives the tokens for cycle parking to students from 1 to 100. Find the number of tokens having digit 8. This problem taken from AMTI examination to make the strong building foundation of problem solving. They solved with systematic approach. They listed all the numbers from 1 to 100. Then they marked the numbers having 8 in ones place. They found 10 such combinations. Then they marked numbers having 8 in tens place. Again, they found 10 more combinations, but 88 was already counted. Hence, they got total 19 combinations a cycle stand vendor can give.
Know that in mathematics, word problem solving is the challenge for students. Here, such a problem which becomes simple by applying abstraction of computational thinking. Students of grade 6, that is the age group of 11 or 12 years, were given a problem. Students were instructed to read the problem carefully and write it down what is given and what to find. Search the number. Identify the keyword, and depending upon the keyword, note the operation. Since the total people in Gitanjali is to be found, so students come up with the abstraction that the people get down is subtracted and the people boarded are added. Now, this is the problem. We can see that with the keyword and notified operation, the students are successful to solve the problem, and they are able to find how many passengers are there at the Bhusawal station in Gitanjali Express. Now, the next problem, the problem of algebra. The word sum of algebra, students feeling little complex. Children were able to solve the word sum with the number systematically, looking for keyword and notifying the operation that we have seen in the previous problem. Here, the numbers are replaced by polynomial. The transition for students was very easy. It is the best example of abstraction. This polynomial can represent anything like money, pens, chocolates. Due to abstraction, complex problems become easy and students are able to find the answer with the keyword spent in subtraction and added means addition. Now, abstraction invites students to identify important information, ignoring unrelated details. Abstraction is the methodology. It makes students to think. Dear friends, actually, natural inclination of students to explore and play, to make strong building foundation of mathematics, exploration of problem solving helps students in math curriculum and beyond the textbook. The computational thinking encourages playful thinking, but gives the structure, and the student learn to solve complex problems with ease. We have blended computational thinking with our maths curriculum, and we can observe that students are eager to participate. They are becoming enthusiastic learners. They are solving the problem systematically. They are overcoming the fear of math. They taking more interest in non-routine problem solving in Maths Club. As we all know that tastes differ and change over time. So dear friends, it's time to change and make the student learning more enjoyable forever with computational thinking. Thank you so much.
Good afternoon, one and all present here. I, Swati Dange, with my co-teacher Rohini Deshmukh and Shilpa Patil, presenting a topic, Steps Towards Happy Learning. A short introduction of our school. School of Scholar Amravati is CBSE affiliated school, started in 2004. We have 2,800 students learning of upper middle class and 92 plus teachers working where we are implementing CS Pathshala since 2017-18 in curriculum for maths 1st to 7th standard, for computer 1st to 9th standard. We have adult tinting lab in which students are working for different projects. We know an algorithm is a set of instructions which when followed to solve the problems or accomplish the required tasks. In computer class, children learn what is an algorithm, how to put the steps of algorithm in sequence. They also choose the best alternative from the different algorithms they develop. For example, going to movie. The students came up with the different alternatives. From there, they tried to create an algorithm. For example, they can go by car, they can go by bus, they can go by walking, according to the feasibility of the transport. Here is an example of our school.
Algorithm help a lot while dealing with the problem solving in mathematics. So we applied algorithm in maths concept. Here are some of these concepts. Multiplication and division, LCM and HCF, addition and subtraction of fractions, tic-tac-toe, even and odd numbers, ascending and descending order of numbers, and guess my birth date.
Multiplying with a single digit number is comparatively easy. Some students face difficulty when multiplying by 2-digit or 3-digit number. For such multiplications, we use algorithm steps. Children were asked to first multiply by 1's place digit value, then multiply by 10's place digit and append a 0 to the product. Then multiply by 100 place digit and append 2 zeros. Now add 3 products to get the final product. Students tried many multiplications with 2-digit and 3-digit numbers one by one in the class by following these algorithm steps. To encourage them, we had a competition among 2 students at a time in the class, and those who will follow all the steps correctly was declared the winner. They enjoyed multiplication by algorithm very much.
For long division, algorithmic steps were interlinked with the family members, which helped them to remember the steps like dad for dividend, mother for multiply, sister for subtract, brother for bring down, and Ramu uncle for remainder. And last step was checking. So this made students excited and motivated them to do many long division problems.
Many students have a confusion when it comes to finding HCF and LCM of a number. We use the systematic steps to let them calculate and it become an algorithm. So to find LCM, student would find the multiples, then find the common multiples, and then find the least common multiples. Similarly to HCF, addition and subtraction algorithm. When students follow the systematic procedure to add or subtract 3 or 4-digit numbers, they get the correct answers. Here is an algorithm that they use to add 3 and 4-digit numbers.
Hello everyone, I am Ms. Renuka Mehta of School of Scholars Amravati, Standard 5th class. Going to tell you the algorithm for addition of 4-digit numbers. Let's see the algorithm. Let's see this with the example. This we have done. Now, this is 1 plus, this is 10 plus, this is 100 plus, and this is 1000. So, we will start adding from the 1. So, 7 plus 12 equal to 12. So, in this, we have to carry. So, here, I will write 2 of the 12 and 1 will be 6. So, it means we have to add this along with the carry. So, it means 5. Now, if the carry is like this, we need to repeat the step 3 of forwarding the carry. So, now we will similarly do the step all. So, it is very easy to get the sum of 4-digit numbers by using of algorithm. Thank you.
Learn with fun Lagori. Children learned various concepts through Lagori. Lagori is also called the Seven Stones Pittu or the Lingrocha, is oldest and most popular game in the India. My students follow all these rules. They played girls versus boys team and developed the winning strategies. They also learned the descending order concept through this game. Any number of people can play it. It required the 7 flat small stones. The size of each stone should be the less than the other. Keep all that stones in the descending order, hit the pile with a ball from a fixed distance. My students followed the rule, they enjoy it very much. The rules are: make a heap of 7 stones in the center. From the center, take around approximate 8 feet distance to throw the ball. One team will bat, one team will field. One of the player of the batting team will throw the ball and one of the player of the fielding team will stand to catch the ball and the others will spread on the ground. Batting team can't cross the boundaries, otherwise they are out. Now player will throw the ball. Aim of the batting team is to arrange the stones back in the descending order and shout Lagori, and the aim of the fielding team is to hit the ball to any one of the player of batting team. Fielding team can't run with the ball having in the hand, they can pass the ball to their teammates. If the batting team is able to arrange the pile in the descending order, they will get the 1 point and all the teammates who are out will alive again. If the fielding team is able to hit the ball to any one of the player of batting team, whole batting team will out and the fielding team will come to bat. The team which score the 7 point first will be the winner. Students loved to play the games. The CS Pathshala lesson on tic-tac-toe was conducted fun quizzes in the classroom. Children even played it on the ground. When they started playing the game well, they could think of the winning strategies also. I would like to mention here, not only the bright student participated, but the shy ones also participated and enjoyed it in the classroom as well as on the ground.
So here the set of instructions were given to the students that write first in natural number across all the composite numbers, and my number is the successor of first composite number, and after that they have to guess my number. So students followed all these examples. They have written the 10 natural numbers, then they cross out the composite numbers, and then the third instruction was the number is the successor of the first composite number. So first composite number was here 4, and the successor of that 4 is 5. That was my number. So here student identified my number. Here student enjoyed the activity and understood how to systematically remove the unwanted number to guess the required number. Next, I conducted the online class activity, Guess My Birth Date. Here student asked me some questions to guess my correct birth date. Each question they asked would remove some numbers from the date of months, and they could guess my correct birth date after few questions. Here student used a systematic approach of cutting strategy for guessing the unknown birth date. Student enjoyed this activity very much, as well as due to this, the concept of maths like natural number, composite number, even and odd number, comparing numbers, etc. All these concepts get revised.
Creating algorithms for problem solving enhances understanding and problem solving skills, which leads to reduction of math phobia, not only in physical school, but also in online school. Here are some examples of students' algorithm who has developed according to their interests. This is an example of 6th standard student who has developed algorithm for how pilots should take a safe flight. This is an example of one more student who has developed algorithm how money should withdraw from bank. This is an example of a student who has developed algorithm how farmer works in field from preparation of soil to transportation of grain. Creating algorithms for problem solving enhances understanding and problem solving skill, which leads to reduction of a math phobia, not only in physical school, but also in online school. In multiplication and division, students to break down complex problem into simple problems, that is decomposition. In even and odd concept, they use colors pattern, that is pattern recognition. In even and odd concept, students to identify important information, that is abstraction. Lastly, using algorithms, students solve addition and subtraction. Algorithm help our students to take a steps towards happy learning. Whenever they came across any problem, they start thinking about the solution in steps. Computational thinking is a great way to open children's minds. CS Pathshala motivated our children and give us such a wonderful platform. Thank you, CS Pathshala.
Thank you, MGS. Thank you so much for the support. Thank you.
Hello, everyone. My name is Ankita. I teach computational thinking and ICT at SCS Gurukul, Pune. I have a total experience of 4 years in teaching ICT, and I have taught in both IGCSE as well as CBSE boards. Before starting, I would like to thank CS Pathshala for giving me this opportunity to talk about my experiences while teaching computational thinking. So, to start, the total number of students in our school is 632, and there are 10 classes with 2 sections each. The number of teachers teaching computational thinking in our school is 6, and we have 1 period per week dedicated for teaching computational thinking for each class. So, for teaching logical thinking and programming to the students through ICT, we have been using Scratch and Python. We teach Scratch from classes 6 to 8, and I think it is a very good tool for learning programming at primary and intermediate level. It is a fun way of learning how to code because it is completely visual. Children can actually see how their program is changing at each level by rearranging certain blocks of codes. They can create games, quizzes, animations. They can build their own stories through Scratch. When I joined Gurukul almost 2 years back, our principal Seema ma'am gave me an objective to integrate other subjects with ICT so that children are able to learn certain concepts in a fun way which they otherwise find boring or difficult to understand. So I thought that Scratch would be a good way to teach some topics from other subjects as it is easy to learn and understand, and children would also take a lot of interest in it. But the challenge for me was to convince other subject teachers to integrate their subjects with Scratch. When I went and spoke to the teachers about it, initially they were a little doubtful about it as they were all non-IT teachers. They did not have much idea about Scratch or for that matter any other sort of programming. So I decided to conduct a small workshop for them and showed them some projects done by the students. Once they all agreed with my idea, the next challenge was to identify the topics that should be taught to the students through Scratch. Some of the topics that we integrated were the 2-dimensional coordinate system from maths, simple electric circuit from physics. We made quizzes from certain topics of social studies. We made different sorts of spirals, which were very useful in teaching angular geometry and understanding how loops work. Now, let's take an example of our first topic, the 2D coordinate system and why we chose it. Sometimes it becomes difficult for the students to learn the coordinate system of maths through graphs. Not all children are capable of understanding such mathematical concepts theoretically. They require a much more practical approach to understand such topics. So, through this coordinate plane, the teachers explain to the students about the X and Y axis and how the position of the object placed anywhere on the plane changes when it is placed or moved to a different part of the plane. This is the program that we used for teaching 2D coordinate system, which we named as the Flying Witch and Hearts. In this program, we have to move the witch horizontally and vertically on the screen using the arrow keys, and we will win a score if the witch eats the hearts that are randomly appearing anywhere on the screen. So the students will be able to move the witch on the stage only when they have a clear understanding of the X and Y coordinates and how they have to change the X axis to make the witch fly horizontally and how they have to change the Y axis to make the witch fly vertically. Expectations were completely met as all of them were able to make this game on their own. All of them looked very happy after completing the program. It would not have been possible for them to make the game on their own if they were not clear of the coordinate system. It was a delight to watch them working cooperatively and collaboratively. It also helped them immensely in understanding how motion works in programming. And as for the teachers, now they are aware of Scratch. They now know that they have an alternate method to teach some concepts practically, which are otherwise difficult to explain theoretically. Following, is a small video in which Manjusha ma'am, who's a maths teacher in our school, is giving her feedback on what she feels about integration of ICT with maths.
Hello everyone, my name is Manjusha and I teach maths at SCS Gurukul. Last year, Ankita came up with an idea to collaborate computational thinking with other subjects. Initially, we were all very skeptical because we did not know any sort of programming. But then, Ankita took us through some of the scratch projects and immediately we saw potential to explain some of the mathematical concepts through scratch. The first topic that we picked up was two-dimensional coordinate system, where I introduced to the students the 2D plane and X and Y axis and how motions of up and down and left and right translate mathematically. The students then went on to build the logic for the program and were very excited when they got it right. It was a revelation for me, and since then we have collaborated on few other topics as well. It was a whole new way of teaching for me. Thank you.
Before ending my presentation, I would like to thank our principal Seema ma'am and the director of our school, Shubha ma'am, for motivating me for teaching computational thinking. It has not only helped our students to learn in a new way, but has also opened doors for us teachers to impart education in a whole new way. Thank you.
Okay, Meenakshi ma'am, you're there?
Yeah, thank you very much, teachers, for the nice presentation. There were small breaks in the audio, but I do hope everyone is able to follow. There were a few questions in the chat room, which were already answered, but maybe I will read them for your benefit once again, some of them. So the session is on mathematics and computational thinking. So the questions related to that would be, just give me a minute. Yeah. So the first question is from Mr. Sundaram regarding the math presentations. Are these not the skills which good pedagogy in math is meant to inculcate? Why give it another name like computational thinking and divert attention from good maths teaching? My advisor, Professor Ramanujam, has answered, and he's already said that, of course, good maths teaching has to be the emphasis, but anything else the teachers would like to add, please? Over to the teachers. You can unmute yourselves and give brief answers if you're free. Mrs. Swati, Mrs. Kalyani, Sankita, Mrs. Rohini, are you all around?
Definitely, sir. It's a maths teaching. But if we are going with the computational thinking, that is decomposition, abstraction, then algorithm, and the pattern making, that means the 4 pillars of computational thinking, if we are applying in mathematics, then mathematical problem solving is very easy for the student. That is our experience that I want to share with you all.
Yeah, thank you. Thank you very much. So let me quickly read out the second question that was there. This is from Sneha Titus. So the question goes as follows. When the algorithmic method is followed for long multiplication, do the children really understand what they're doing? Or is the focus on the process, not on the product? I think this question is specifically for the teachers who taught them multiplication, numbers and polynomials using mathematics. So would one of the teachers like to answer that?
Yeah. When 2 by 2 multiplication becomes very difficult for few students. So in that case, if you're following the algorithm steps of very first few examples, then it will be clear to students how to get the solution. That's why algorithm steps are helpful here to get the solution.
Thank you very much. Anybody else would like to answer it? Otherwise, I think we could close the session and hand it over. Okay, thank you very much. Thanks to the teachers once again for joining in and for submitting your abstracts. It was a pleasure listening to all of you. So I'll hand it over to Sonia back again, or to Pratiksha, sorry, who would be the session chair for the next session. Thank you.
Thank you, ma'am.
Hello. Pratiksha, you can unmute yourself and start. Sonia, should I start the next video or is Pratiksha?
No, where is Pratiksha? Pratiksha.
Yeah, Pratiksha is unmuted and I see her. So Pratiksha, if you could please speak and start.
Pratiksha ma'am, you can remove your headphones if possible. It can be because of headphone, the volume is not coming.
Yeah, am I audible now?
Yes, you're audible.
Yeah. Yeah, I welcome you all. Thank you, Shanti, first, and thank you, Meenakshi. I welcome you all to the second session on information representation. Here we have with us Boledu Nandakishore from Andhra Pradesh Social Welfare Schools. He is going to share his experience on making children understand representing information. So I welcome Nandakishore also for the talk, and over to Shanti for the presentation.
Yeah, I'll share the presentation. Just a minute. Share करना ना. Is everyone able to hear?
Yeah, we are able to hear.
Arun, I'm not able to hear the audio for the presentation.
Arun?
The presentation audio is not visible.
Yeah, you need to share the computer
Arun,
audio as well.
If you are wearing headphone, please remove the headphone. It can be because of the headphone, the issue could be there.
Yeah, just give me a minute.
Yes.
Full screen share.
Hello? No, now though you will take the questions for his session as well. ठीक है, अभी आप ये वाले सेशन पे concentrate.
हेलो, ऑडियो अभी नहीं आ रहा है अरुण जी. हेलो.
Hello.
Sonia, you are unmute. Hello. Hello.
एक मिनट. Now tell me, can you hear?
Yeah. You try. Otherwise, I can try.
Yes.
No, we are not able to get the audio yet. Arun, shall I try once? Hello, Arun. Hello.
Teachers, while we are trying to fix the video, can you all take the poll? Let's see how many teachers we have in the audience today.
Yes. Arun, shall I try?
Hi everyone, I am B. Nandakishore. Hi everyone, I am B. Nandakishore, working as an ITCT trainer in social welfare schools. Today, I want to talk about some really interesting experience of my teaching and also want to share my way of teaching with you. Topic which I choose to share my experience is representing information. Before going into the topic, I wish to talk about my school. Our school is a government school located in Andhra Pradesh in a beautiful village. Children here are from illiterate families where the whole family must have to go to farming works or any daily wage works so that they could feed their children. We don't have private schools in our area, so students need to travel long distances for schools from the neighboring towns. I started the session by telling the importance of Lipi, where Lipi is considered as writings, letters, or any alphabets. As we elders have already lived and become habituated to current world we live in, we don't face many problems. But imagine a newly born kid, or say like a person from PK movie, comes to our world and tries to live here. He would face many difficulties, like why should he ride a bike or
Hello,
car on
Arun.
the left side of the road,
Hello, Arun.
or he might get confused with rules and laws which we currently use in our world. Same is the situation with a learning kid. He is new to all this generation stuff. He doesn't have any idea about some technical things like. Hi everyone, I am B. Nandakishore, working as an ITCT trainer in social welfare schools. Today, I want to talk about some really interesting experience of my teaching and also want to share my way of teaching with you. Topic which I choose to share my experience is representing information. Before going into the topic, I wish to talk about my school. Our school is a government school located in Andhra Pradesh in a beautiful village. Children here are from illiterate families where the whole family must have to go to farming works or any daily wage works so that they could feed their children. We don't have private schools in our area, so students need to travel long distances for schools from the neighboring towns. I started the session by telling the importance of Lipi,
Sorry, there is some technical actually glitches. So we are just fixing it soon. It will be there, and very nice to see that we have around a good number of teachers here today. And we have some principals also participating in this, some CS Pathshala volunteers, and some other members are also here.
While we are waiting for this to fix, let's see how many of you teach computational thinking in schools. Can we all take the poll?
Yes.
Is a government school located in Andhra Pradesh in a beautiful village. Children here are from Hi everyone, I am B. Nandakishore, working as an ITCT trainer in social welfare schools. Today, I want to talk about some really interesting experience of my teaching and also want to share my way of teaching with you. Topic which I choose to share my experience is representing information. Before going into the topic, I wish to talk about my school. Our school is a government school located in Andhra Pradesh in a beautiful village. Children here are from illiterate families where the whole family must have to go to farming works or any daily wage works so that they could feed their children. We don't have private schools in our area, so students need to travel long distances for schools from the neighboring towns. I started the session by telling the importance of Lipi, where Lipi is considered as writings, letters, or any alphabets. As we elders have already lived and become habituated to current world we live in, we don't face many problems. But imagine a newly born kid, or say like a person from PK movie, comes to our world and tries to live here. He would face many difficulties, like why should he ride a bike or car on the left side of the road, or he might get confused with rules and laws which we currently use in our world. Same is the situation with a learning kid. He is new to all this generation stuff. He doesn't have any idea about some technical things like say how a movie is coming onto the screen, how a Wi-Fi works. Such things would be very fascinating to a new learning kid. Hence, I thought it would be best to start my teaching from the older civilizations, like how they passed their knowledge to the further generations and giving my touch of representing information in daily lives and how it will be helpful to understand the situation without much of an effort. Here you can see some pictures which were drawn by prehistoric people. I showed these images to my students and asked if they could identify any pictures drawn, to which many children shouted their versions of answers. Then I told, see, without knowing these humans who drew these pictures, nor their languages, you could understand what they want to convey, isn't it? After showing the prehistoric images, I showed some general signs or words which we see in our daily lives and asked them how many of your students can identify these signs or words, or have you seen them anywhere? Asking such questions has really brought students into the topic. After showing these images, I thought I could give them an activity, a general activity, such that I could enhance the thinking of students. I asked the students if they could design some signboards, to which I would say the context. They were all ready with their pens and papers. A signboard for which to walk in a line, open laptops and start working, relaxing after school. These were the contexts I've given to them. They have drawn such caricatures with their intelligence and understanding capacities. After the drawing activity, I drifted my topic into a related context for a chapter, which is representing information, by asking another question. How can a computer draw? To draw a picture, what did you do? You took a pen, paper, and you drew with your hands. But would you believe me if I say the picture you are watching currently and the movies, photos, songs which you see or hear, students were filled with so many thoughts. So I tried to elaborate and explain to them with the activity given in our material. So what the activity does is, it has zeros and ones where the student have to mark only ones or fill only the blocks with ones. After filling them, he would get a picture. They started noting down the figure and darkening the colors. Then I said, what does the symbol look like? Some shouted, it has a ghost symbol. Some told a smiley. Then I had to make them silent and told them, this is how a computer draws. To get deeper into the subject, I showed the next slide. Here you can see a dotted LED red board. So I showed this picture to the students and asked if they had seen it anywhere. Some said they had seen it in railway stations, buses where the destination boards are held. And in our school also there is a clock similar to it. Some children even told that too. Later I told, by increasing the LEDs light, if there are 80 LEDs in the picture shown, if we increase them to 160 LEDs or 200 LEDs, the picture would be crispier and look like this, which is an 8-bit picture. If we increase the LEDs furthermore to say 1000, then the pictures will look like this, which are the photos or the pictures students see them. Then I said, this is how the evolution of pixels and the high resolution pictures which you see in your daily life has emerged. This is how I thought would reach the children in an efficient way of representing information. I want to talk about impact my class created on the students. I've got several questions out of which I will address two questions. Student asked after this class, how could a computer be able to sing? This is a big one. Even though I knew I could answer it, but felt hard to give students such complex answers, which in turn would confuse the student even more. So, what I told is, sound is in wave form, like C waves you see. They are converted into digital zeros and ones, like a switch has on and off, zeros and ones. Then the input is given to a speaker. A speaker is a sound producing unit, like every object in our world. Like if you take two plates and bang them together, you will hear a sound, isn't it? Same, likely, the speaker also produces sound according to the input given. It increases the sound or amplifies the sound and produces songs. This is what I gave them. But there is much more tech inside the generation of audio from the computers or machines. But I hope I have given the interest required to learn it. When he has physics class and sound in his 8th
अरे
or
वो
9th,
मैं उसको मैसेज कर रही हूँ कि तू इम्पैक्ट डायरेक्टली लाइव बोल नंदकिशोर को ये बंद कर देते हैं वो करने को तैयार है रुको
how could we get a color
Arun?
picture, to which I didn't have to struggle a lot because some students are wise enough to figure it out that it's a color LED. Many students were excited to learn about the technology inside the computers and displays and about the life forms, how they communicated in their ages by representing information amongst them, which gave them a wider subject to think about. I feel my session has brightened up the students' mind and shed some light on the topic of representing information in different ways and could never be forgotten. Now, coming to the conclusion, I could just start the class from, say, computers can understand zeros and ones only, and by combining zeros and ones in various combinations, we can produce.
Yeah, we are sorry for this technical difficulty. So we will have Nankishore share the impact of how he taught in class live with us. Nankishore, can you start?
Yes, definitely, ma'am.
Thank you, Nankishore. I'm so sorry about this problem.
Okay, ma'am. It happens when it's okay, ma'am. Okay. Now, coming to my topic is representing information, which will be taught to the students from 5th class to 7th class in our social welfare schools. Ma'am, can anyone tell me if I'm audible or not?
Yes, Nandakishore.
Yeah,
Thank you. Thank you. Okay. So the total reason for teaching in my way is so that I could just sparkle a bit of curiosity in the children, and they could think about the older generations and how they passed their knowledge to the newer generations, and how the humans have evolved in such a way so that every human being which we see or live in the current generation are developed and matured in different ways. So as ma'am has mentioned about talking about the impact on the students, I would like to talk about this topic now. Actually, I told the students that a computer can sing, a computer can draw, a computer can also play videos. So I just demonstrated how a picture can be drawn by a computer, but the students kept that in mind, that how would it be able to sing? So uh, even though I know that it is a tougher subject for the students of 5th to 6th and 7th standard students, uh, I thought I could explain it to them in my way so that they could get an idea, and in future generations, and I mean in future classes when they want to listen to the physics class or respected classes, they will have some related topics like we have a physics sound lesson, so they would get interest in listening to such classes based on my class. Okay, the question asked by the student is, how could a computer sing? I told them a computer has understands zeros and ones only, no? So the computer, in order to understand zeros and ones, what we did is we converted the analog signal, which is a sine wave signal. I'm sorry, sine wave to analog, which will be like a incremental form and will be decremented to zero. The highest peak would be 1, and the lower crest or troughs will be zeros. So rather than saying like that, I told, have you seen C waves? So the computer imagines the sound has been created in zeros and ones, like a switch has on and off. The sine wave is converted into an analog, or sorry, a digital symbol, like zeros and ones. When an series of zeros and ones are placed left to the right, then the computer understands the variations in the zeros and ones and then plays accordingly to the song. Even though such examples are a vague answer, but I thought my explanation has given some scope to the student to think about such such technology which we live in, like how a Wi-Fi works, how a computer sings. In his younger ages, he wouldn't be needing that much information, but he would be interested to understand or to learn how this world is working right now. Okay, that would conclude my impact on the students. Another question a student asked is, how could you said you have shown red LED boards, no? Then how could a color LED be visible? I mean, students who see currently are all current LEDs. We don't have black and white TVs in our generation, right? So a student has asked that doubt, to which I don't have to struggle a lot, because some students are wise enough to figure it out, like it's a color LED. Like a color LED may or might produce different colors, which is the right answer to an extent. Okay, that would conclude my impact, ma'am.
Yeah, thank you, Nandakishore. Yeah.
I would be very happy to take any questions.
Yeah, thank you, Nandakishore, and sorry for the technical issues that we faced. I hope the things were clear after the presentation started. Okay, so thank you once again, audience, for patient listening, and thank you, Nandakishore, once more. Over to Shanti.
Thank you, Nandakishore. It was really nice. You explained it so well. Hello. Hope you can hear me now.
Yes, yes, we can hear you.
Yes, yes.
Yeah, yeah. So thank you so much for explaining it so well. And now over to Vipul. Hello.
Yeah, thank you, Shanti. Am I audible?
Yes.
Okay, great. So do we also have the speakers for this session ready as panelists?
Yes, I have promoted.
Wonderful. So while they do that, I think let me just get to introducing them. So Sridhar earlier spoke about teaching CT so as to nurture the next generation to become creative problem solvers, right? Why did he say that? And one of the things is perhaps because problem solving has become a critical skill in all the walks of life. And come to think of it, we seem to need this skill every day. Later tonight, we are going to hear from Professor Janet Wing, who coined the term computational thinking. And she defined it as a thought process involved in formulating a problem and expressing it as a solution, or expressing its solution in a way that a computer or computer, human, or a machine can effectively carry it out. So, whereas design thinking attempts to identify why the problem exists in the first place before solving it. So I'm quite excited with a couple of programs from TCS Corporate Social Responsibility Division that will be coming your way. One of them is Ignite My Future in Schools, which has been running in US. It's application of CT. And Sridhar earlier again spoke about how to train students on applying CT. And the other program is GoIT. And today we have Preeti and Bhagya from TCS to provide us a glimpse of the GoIT program. So I welcome them. Over to you, Preeti and Bhagya.
Thank you so much, Vipul. Is my voice audible?
Yes, you are.
Okay. I would be sharing my screen also. Can you see the screen?
Yes, Preeti.
Okay. Yeah. First of all, I would like to thank the entire team for having us over here. We were really excited and looking at the presentations that happened and the kind of talent and the energy and enthusiasm that everyone in this group has. I think so that it is a wonderful, wonderful platform. And thank you so much for having us over here. So today, along with me, Preeti, I have Bhagya, who is also from my TCS GoIT team, and we would be taking you through one of a very, very what can I say? It is a very innovative program, something which is very new, and I'm sure it is something that will be liked by all of you. So the name of this program, as you can see on the screen, is GoIT. Okay, so it's Go, who is written in blue, and the IT, which is written in green. So you can understand exactly what this program does. But there is much, much more to it. And I would like to take you through the next slides, which will explain this program in detail. So, GoIT is a program of Tata Consultancy Services to empower digital social innovators of tomorrow. I'll quickly go to the next slide. GoIT is a TCS flagship STEM program. We already heard about STEM in the previous session, and it's Science, Technology, Engineering, and Mathematics program. And this program is to empower school students to become digital social innovators. Okay, so it is digital, it is social, and it is innovators. These three are some heavy words, but they are very, very powerful. How are we going to do it? We are going to use the concepts of design thinking and technology to solve problems. The vision of this program is to strengthen the communities today by empowering digital social innovators of tomorrow. So there are some nice pictures that you can see popping up on the screen that gives you an idea of what the program is about and how the children are enjoying it. So going into some more details about this program. So it is a modularized content which allows flexibility, scalability, and open access to all learners. It's a curriculum which is ready, which is free for all the users, and it is 6 hours to 20 hours of curriculum. If you just see below that, it is deployed for students from first standard onwards. So now you will say that, Preeti, how can one program fit for all these students? So the curriculum is such that we have designed the curriculum that it can suit to different age groups, and it can be customized for different age groups, with the elder children taking the concepts of mobile app and devising solutions using mobile app. It also incorporates the 21st century skills. Some of the skills to be mentioned: problem solving, obviously, along with design thinking, creativity, innovation. And if you can see, it's TCS and client mentors over there. So when I was a kid, I loved going to my father's office and meeting some of the seniors, and they were actually like kind of teachers also for me. I always loved taking guidance from them, and we really feel that the students are very happy when they interact with the TCS and the client mentors, and they look up to them and they learn a lot from them. So that is where we have brought in this picture also, that we give for our students. Whatever the solutions that the children will develop, those are directly tied to the UN Sustainable Development Goals. So there are 6 modules in this program, and after the completion, they get a certificate from TCS. So now let's take up a poll. Um, I would request Arun to please help me in this, and you all will be getting a poll on your window. I would request everyone to please answer that poll.
Yeah, Preeti, I'm helping you. Sonia here.
Yeah, thank you. So the first question that must have been popped up on your screen: are you aware about design thinking? So we can take a minute and then answer this question. Are you aware about design thinking? Let's give some exercise to our fingers as well as our brains when we give this poll. So once the poll is over, I would need some help from you in displaying the result.
Should I end the poll?
Yes.
Okay, great. Preeti, can you see the results?
No, it's yet to pop up. Yes, I can see it now.
Yeah, great.
So the percentage is, to read out, it's 26.7% of the teachers and the audience over here say that yes, I practice it in my classroom, which is really good. And 73.9% of them say that no, and they would like to hear more about it. So it's very true. And to be honest, design thinking was very new for me also. When I learned more about it, I understood it's a wonderful, wonderful way to solve problems, to solve complex problems. And once we go into the details of this program, you will understand how this program uses the concepts of design thinking to solve the problems. So with this, I would like to go to the next poll. Again, some exercise for your fingers. Do you know about the UN Sustainable Development Goals? So this is the next poll that will pop up on your window. Do you know about the UN Sustainable Development Goals? So if you know some of the goals, I will suggest that you can go for the answer somewhat. If you know all the goals that are there, you can go for yes or it's a no. I can see a chat that says all goals. That's excellent. Okay. I guess we can
End
close
the
the
poll?
poll now.
Yeah,
Yeah.
okay.
Okay.
Preeti, can you see it? Yeah.
So, yes. So 25% said yes. That's really good. And I'm assuming this yes is for all the goals that are present. 53% said no, and 21% said somewhat. So that's good. So this is also a very good point that I wanted to bring out in this poll. And now the last question: would your students like to design mobile apps to solve problems? This is the last poll. So the last exercise for your fingers. And I'm really happy to see that in the responses we are getting some of the SDGs that are there. So that's really nice. Thank you. Would your students like to design mobile apps to solve problems? There is one question: where is the poll site that I can see in the chat? I guess it's a pop up that you can all see on the screen. I guess we can end the chat.
End
We
it?
can end the, yeah,
Poll?
poll.
Okay, yeah.
Okay, that's a wonderful answer. So 69% of the audience over here said that yes, they would like to use mobile apps to solve the problems. 10% said no. Obviously, everybody would be having some of the restrictions and so on, and 20% said somewhat. So that's really a very nice response. Thank you, Sonia, and for coordinating. And with this, I would like to take you through the goals of the GoIT program. Even in the earlier session, even I remember Nanda Kishore had also said about sparking the curiosity among the children. And yes, children are very curious. And that is why it's very important that we have to make the students develop this curiosity. Rather, develop, I will say, bring out the curiosity that is there in them. Many of the students feel that computer science, computer skills is something that, it's very difficult. They will not be able to do it in the right way, but that's not true. So we all try to ensure through this program that they have a wonderful, wonderful time with us, and they really enjoy it. They develop the skills slowly, along with them being comfortable and enjoying. As mentioned earlier, yes, they meet the industry experts, they have mentors from the industry. I want to guide them throughout. They have a place where they can share their ideas, they can share what they have thought about, they can develop certain models, and with the help of the skills, they develop solutions, and they also come and present these solutions. So while presenting, yes, it does help in building the confidence. We do guide them on how a presentation has to be done, and then with this, we come to the end of the program where they come and they pitch in what they have done. So I would like to go to this slide, and I would like to spend more time on this slide so that we get a fair idea of what the GoIT program does. So as mentioned earlier, there are 6 modules that are there for this program. The content is customized for different age groups so that every child will have a wonderful, enjoyable experience going through this program. And the first module talks about STEM and computer science. So over here also, since they are children and we know they are super creative and super innovative, we teach them STEM with the help of certain examples where they can actually practice STEM and understand how these 4 departments are related to each other. Obviously, there is computer science and how computer science can be used in our day-to-day life. That is what this module speaks about. Second module, a very interesting module, is about design thinking. Now, for the children, the term design thinking might be, for them, they think it's only creativity. And to be honest, when they understand this, the kind of solutions or the kind of inputs that they have given were tremendous. So we walk them through the stages of design thinking, and we all say that empathy is the heart of design thinking. So for students, why they like this module the most is that they themselves identify the problems, they feel empathetic towards a particular problem, and this is not what we teach them, this is what they develop, they understand, and once we just explain it to them, they say that yes, this is what I have felt. So they themselves understand the problems, and then they feel that no, I want to solve this problem. So that is where the children enjoy this module. Module 3 is where they identify the problem in the community, and this is where one of the poll questions that I had asked for was the SDGs. So we give them an idea about the SDGs that are there, and they will identify a problem in the community which they see, and then that one problem is the problem that they would like to solve. Over here, the students are free to choose their problems, whatever problem they feel they want to solve, and that is where they come in with a lot of creativity. We also give them a basic idea about innovation, and yes, there are certain games which are there in this entire course which they do where they innovate and then they enjoy, understand how creativity and innovation comes together. Module 4 speaks about visualization. So it's UI, UX, user experience, user interface, wireframing, and storyboarding. And this is one exercise where we also speak about children using their visualization methods, colors. We talk about STEM, and then it is STEAM where the arts part is there. So over here we speak about using colors, crayons, sketch pens, whatever they want to, and they become creative and they visualize what will be the solution to the problem. Module 5 is where they go for the app development. And this is where they develop a mobile app for the problem that they have identified. And then they come and pitch their concept in module 6. So if you understand how all these modules are linked to each other, is that the students are empowered that they solve the problems that they see in the communities. They will have an idea about STEM, they will have an idea about computer science, they will use design thinking to solve the social problems. They learn visualization methods, which we feel is very important before directly coming to the solution. They should understand, have a fair idea of how their solution looks like. So that's the visualization part. They also use technology to solve the problem. So in this case, the technology that they are using they will be developing mobile apps. And obviously, they once they pitch in and they are comfortable, they cover all these 5 modules. They speak, they interact with the industry experts, they gain their confidence and enhance the presentation skills. And obviously, the favorite part for the students is where they interact with the industry experts and they understand and they share their ideas. Okay, so what will you like about GoIT? So this system that I have shown on the left hand side where it's TCS community and school. So this is a program which is a combination of TCS, the organization, community, because we are solving the problems in the community with the help of schools, with the help of school children. So what GoIT has to offer is that we give insights about STEM design thinking, how to apply design thinking to innovate and solve social problems in the community, discovering new visualization methods such as creating wireframes and storyboards. Uh, Children have heard wire, children have heard frame, story, and boards. That is what the children tell us every time when we ask them, have you used this word? But they are not aware of wireframes and storyboards, the two words. So then we teach them how they can understand and how they can visualize the solution to the problem using these methods. Teachers can also explore new ways of using technology to design the solutions to the problem. So, right now, mobile applications they can develop. This program empowers teachers with additional tools to increase student engagement by amplifying students' voices on topics students are most passionate about. So, over here, when we did this program for certain students across, and we found that there are certain topics that a student would like to develop more interest in. Might be it is environment, might be it is education. So, what teachers can do is that once they understand there is one topic which the student is most passionate about, the student has understood that this is the problem that they want to solve, the teachers can use these tools to solve those problems. And obviously, since we are there, so along with us, we'll be calling different industry experts, and then we can have access to industry experts in your classrooms. So this is where there'll be talks by different experts across the industry, and they will give insights to the students about latest technology and few more points. So this was an overview about the GoIT program. If you're interested, if you want to know more, I understand that since it's a virtual conference right now, so we won't be able to solve much of the problems or much of the questions that come up during this session. Yes, we would surely meet you again at 5 o'clock, I guess. And till then, if you have any questions, anything that you want to know more about this program, you can get in touch with me and Bhagya. I will take a minute and you can write down our email IDs. So these are our TCS official email IDs. You can drop a mail to us to know more about this program. So I'll pause over here for a minute. If you want to make a note of the email IDs, please do that. I believe Bhagya has also pinged in the chat window. If you can simply copy paste the IDs, you can do that too. Thank you, Bhagya, for pinging in. And with this, we thank you all for having us over here. Thank you for patiently listening to this program. This program is really very exciting, very close to us, very close to our organization, and we have seen it impacting the students in a very positive way, students and the communities in a very positive way. So thank you, Vipul and team, for having us over here, and thank you all. And please get in touch with us if you need to know more about this program. Thank you.
Thank you, Preeti. As you mentioned, this is for all the participants in the breakout after we are done with the next session. Preeti and Vagya both will be available in the breakout session too. And if you have any questions, I'm sure they'll be happy to answer your questions, some more details about this program. So just a very quick question here, Preeti. Is the GoIT program open to all?
Okay, so the question is the GoIT program open to all? So I believe it's you meant all students, right, Vipul?
I guess the question here is probably interpretation is there any charge for this? Is it open to students, all types of schools, for everyone basically? Yes.
Yes, it is open to everyone. It is open to all the students that are there. It is a free of cost program. It's not chargeable, and as I mentioned, it is currently we have deployed it from first standard students onwards. So it's open to all. In short, to answer the query.
Okay. So I think in interest of time, I think I'd like to thank you again, Preeti and Bhagya. We will probably have more questions in the breakout session. So thank you again, and over to you, Shanti.
Thank you.
Okay, thank you, Preeti and Bhagya. It was really nice. And Sonia, hello. Now the next session chair is Sonia. So Sonia, are you there?
Yeah, thanks, Shanti.
Okay.
So shall I start the video, Sonia?
No. We have something before. I'll tell you when to start the video. Thanks, Arun. Yeah, so I would like to welcome all of you to obviously one of my favorite parts of our implementation, the Bebras challenge. And I'm just going to share my screen. The first question that I have for everybody obviously is, how many of your schools participated in the Bebras challenge? These are numbers that I've just put on the slide. Vipul has spoken about it, so I'm not going to repeat any of it. But Bebras India challenge is conducted by CS Pathshala in India. And now, Arun, will you launch the poll question?
Yes, give me a minute.
Yes, so can we quickly have some responses on this question? This question everybody can answer. Come on.
50% have voted till now.
Yeah, let's give them a minute. Yeah, okay. Arun, I think we can end the poll. Yeah, so as like all of you can see, we have 56% teachers who said they've participated in the Bebras challenge and 44% haven't. But believe me, today's session is going to walk you through enough Bebras tasks. Hopefully by the end of the session, you'll be excited about it. And just to quickly yeah, so to just quickly brief you about 2019 Bebras India Challenge, we have had 178,239 students from 647 schools across 15 states in India. What I would like to share with you, which is more important, is that, you know, of these, we had 143,808 students from 455 government schools from Andhra Pradesh, Gujarat, Maharashtra, Tamil Nadu, and Telangana. And see, all of you know about all the impact stories that I like to share with you. I will come back to that later. But, you know, getting all these schools and all these students to participate was one of the most exciting part of conducting the Bebras challenge. And so that we are able to include most of them, we run it in a hybrid mode, online, which a majority of the elite schools take, and offline is schools that have computers, but no internet. So they conduct it offline and then they upload the results. This is conducted for classes 3 to 12 with English. Obviously, to include more students, we offer it in regional languages, Gujarati, Marathi, Tamil, and Telugu. And another important point is that this Bebras challenge is conducted in the schools under the supervision of school teachers. Just to give you a brief on the 2018 Bebras challenge, it was offered in 4 languages and we had seen participation of 137,000 students from 11 states. This was an interesting partnership that we had last year with Sakar Papers. So what happened is that, I'm not sure, at least people who are from Pune or from Maharashtra are aware of the Sakar NIE student editions. These are school editions that go to schools. And this is a full page picture that I'm showing you. So half the page is dedicated for Bebras challenge. So what they do is they put in one task and the next week is the solution for this task. So all the children get an opportunity. And the reach out of this newspaper is 35,000 students, urban and rural, across 300 schools in Maharashtra. Now, what is very interesting is that this was something that I saw because when one of the teachers training programs, we have from Sakai and we were there part of the training program and we had carried these newspapers. You should see the excitement the students have, you know, when they get this newspaper and they all turn to look at the Bebras challenge and solve. And another thing I will tell you very interesting, I was in the Sakai office doing the teachers training, and when I came out, they all said, oh, you know, we also solved the Bebras challenge. The point that I'm trying to put here is it is open to all ages. So I'm really looking forward to your participation in this session. Okay, now I'm sure the next question would be, when is 2020 Bebras India Challenge happening? Due to the pandemic, it will not happen in November. We will be conducting it in January 2020. And who should participate? The challenge will be open for all age groups. Like I mentioned earlier, it's open for all classes 3 to 12, and this is conducted free. And I would request all of you, you can take down the website, but it is bebrasindia.org. Please refer to the website for updates. And we will be putting up the dates there for registration. Yeah, another thing I would like to add is student registration has to be done through the schools only. Okay, without wasting more time, we have Madhavan Mukund from Chennai Mathematical Institute. He is the Distinguished Professor, Deputy Director and Dean of Studies, CMI. Madhavan is passionate about CS education. He plays an active role in ACM India CS Pathshala initiative and Bebras to introduce computational thinking in schools. Over to Madhavan for an overview of the Bebras Computing Challenge and also how it is used to introduce computational thinking to schools. Thank you.
Thanks, Sonia.
Yeah, over to you.
Okay, so as Sonia mentioned, Bebras has been held in India for the last 2 years, and we are looking forward to the 3rd edition. So I'd like to just walk you through a little bit about the history of Bebras and how actually Bebras works in practice. So Bebras is an international initiative to promote computer science, or as it is called in some European countries, informatics in schools. So I first heard about Bebras because of my involvement in the Informatics Olympiad, which is the equivalent of the Maths Olympiad for computing. And Valentina from Lithuania created this Bebras competition in 2004. And about 2 years later, it spread to other European countries. And now it's a truly international contest. And in case you're wondering about this strange word, Bebras. So Bebras is the Lithuanian word for beaver. So beaver is an animal which some of you may have heard about, not found very much here, but basically it builds dams by kind of damming up rivers with logs and all that. So she was impressed by this systematic process by which beavers build dams and felt it was a good emblem of this contest. So the original motivation for this Bebras contest was actually quite narrow. It was actually to feed more students into a programming stream at senior school. But I think over the years now, in the last 10 or 15 years, everybody has come to realize that computational thinking, as we heard from Sridhar, is much more than programming. And actually, now the broader goal of Bebras is actually to inculcate a computational thinking skill with the goal that some of these people will also take up programming as a future career. So Bebras is essentially a problem-solving contest, and the way it calls itself, it's a Bebras challenge. About 70 countries participate in this right now, and there are some 52 full members. That these are people who frame the rules and the procedures for the whole thing. And I'm happy to say that though we started participating by running contests only 2 years ago, India has been accepted as a full member this year. So we are now a full-fledged part of this community. So the way that Bebras works is it's really a community effort. So every country which participates contributes problems. So some contribute 3 or 4, some contribute 10 or 15. Typically, India has been contributing 10 to 15 problems a year. And so we have a pool of about 200 to 300 problems which come out of this. And then there is a workshop where each country sends representatives. So this year, like everything else, this workshop was held virtually, but it went off very smoothly nevertheless. So in the workshop, the participants actually work. I mean, unlike many other workshops where they sleep. So here, actually, people sit around in groups of 8 or 10, and they they subdivide these tasks into buckets of 20 tasks each. So there are about 10 groups maybe, and each group's task is project is to refine some of these tasks so that they can be used for the final form. So the goal is to maybe produce 100 usable tasks, so that there is a variety of tasks that each country can then choose from for their national challenges. So every country is now free to take. So these are all now a common repository, which is available for all the participating countries to pick and choose the tasks which are most appropriate for them. So what is a task? A task is essentially a problem. Sometimes it looks more like a puzzle. And the intention is that it should be solved in, say, 3 to 4 minutes. Now, tasks are graded according to the age group. So these are the international age groups, 6 to 8, 8 to 10. So you can think of it as class 1, 2, class 3, 4, class 5, 6, and so on, up to senior school. In India, we typically use only from class 3, 4 onwards, because it's kind of difficult to explain to the younger students how to approach the tasks. And along with this age grouping, there's also a difficulty level. So tasks are classified as easy, medium, or hard. Now, notice that, of course, the difficulty level is age specific. So you can have the same task, which is easy for a higher age group, medium for a lower age group, and very hard for a younger age group. So in recent years, it has become for people setting the tasks in order to make sure that it is kind of connected to this goal of computational thinking. There is a part of the task writing process which involves explaining in what way it is connected to computing. So there is a section called It's Informatics, which is actually part of the task description. So this helps to ensure that the tasks all have reasonable grounding in the subject. So I'll just walk you through 3 tasks which were actually selected last year and were selected for the Indian Bebras, just to show you the different varieties and also the different levels that can be there. So this first task is called Scratch Art Paper. So the idea here is that you have these 4, the center picture shows you these 4 colored backgrounds. And on the top, you put black paper. And then if you scratch the black paper, depending on where you scratch it, you see some of the picture colors underneath. So the task is now given these pictures that you are going to scratch out and imagining that there are these 4 colors below, which of them is going to produce exactly 3 of the 4 colors. Okay, so just to show you the 4 colors, they are basically arranged in this way. So now you have to take these 4 pictures and imagine which one of them will produce the 3 colors. So this, if you notice, is a little, I mean, one of the things to notice is that there is relatively little text. So a lot of it, this is a typical feature of a Bebras task. It is designed for younger children typically. So a lot of emphasis is on having a visual picture. The problem is, as far as possible, illustrated in a visual manner. And especially for the younger groups, this one has a little bit more text than normal. Especially for the younger groups, the emphasis is on trying to make the text as simple as possible. So less reading. Remember, you have only 3 or 4 minutes to solve the task. So you shouldn't have a long time to have to read and understand the task, because you also need to solve it. The other thing is, of course, these are international tasks. So here the flag indicates that this was a task contributed by Korea. So then we have this gradation. So this particular task in the Indian Bebras was graded as medium for the youngest group in the India set, which is class 3 and 4, age 8 to 10, and easy for the next set, class 5 to 6. Right? Now, internationally, actually, this was one level lower. So this is another thing, that each country is flexible to choose what it feels is the appropriate difficulty level and age group for a given task. The other part which you don't see if you see the finished product of the task is usually this connection to informatics. So here, if you look at the original task description, you will find that they explain the connection in terms of, if any of you have used tools like Photoshop or GIMP or something, then typically any image manipulation tool actually organizes these things in layers. And then you have transparency and background colors and all that. So this kind of superimposition of one layer on another in image is quite common when you do image manipulation. So this is one example of a Bebras task. So let's move to a slightly more complex example. So this is again an example from last year, which was used in India, and this was contributed by Germany, and it's called car parking. So here you see a picture of cars being parked. The cars which are parked have letters on them to identify them. And the goal is to identify which car needs two cars to be pushed away before it can leave its parking place. So for instance, if you look at car F, right? Car F is blocked by car O. So F is the 6th car in the vertical sequence. So actually, if you move car O 2 slots to the left, you can move out car F. So car F does not require 2 cars to be pushed. So you have to figure out which 2 cars have to be pushed. So this is a slightly more complex task than the first one. And this appropriately is at a higher age group. So it is considered to be hard for this youngest age group, medium for the class 4 to 5, and it is, sorry, the last one should be easy, not hard. It's easy for the highest age group. Okay. So here, the idea that is being illustrated is that you have to search through the space of solutions. You have to look at each car and what you need to move, and then go back and forth, and then figure out systematically for each of the things what you can minimally move in order to release the car. So the last example which I will show is this thing called marble track. So here you have these kind of sloping thing on which a ball drops down, and as it drops down, you can see these kind of rotating, whatever you might call them, little trays, which can flip left or right. So when a marble falls, it kind of flips the tray. And now you have to figure out, after some marbles fall, what position the trays are in, right? So initially you put it in 0, and then you put 10 marbles rolling through it. What would be the final configuration of this tray? So this requires still more complicated reasoning than the previous one. And so this is for the highest age group or the next to highest age group, 14 to 16, this is easy, but it becomes subsequently harder for lower age groups. And here, the obvious thing, if you think about it, is that these rockers or these trays represent bits. And so each time you're kind of incrementing the bits. So this is actually something about binary counting. So this, by the way, if you can recognize the flag, this is an Austrian task. So these are 3 examples of Bebras tasks, just to show that they are typically visual tasks, so that there is a picture illustrating usually what needs to be done. Depending on the level of the question, the text could be a little more or less, and the concepts involved are also graded according to the reasoning capabilities of the different age groups. So when we conduct Bebras in India, it's not, I said that there are these tasks which are selected and shortlisted and refined in this workshop, and then they are put into this central pool of tasks which any country is free to use. But the problem of using these tasks doesn't actually stop there. So one thing is that many of these tasks may need to be adapted, right? So they may refer to concepts from the country in which they were created. So there might be references to European animals or to other kinds of things which are not familiar to Indian students. So sometimes you have to adapt the context, make the problem statement more India specific. And the other thing, of course, is that the age groups and the difficulty levels are not necessarily cast in stone. So you don't necessarily have to choose the same level that people have assigned. You might decide based on this that depending on what our students study in school, some things may be easier or more difficult, and we can adjust the age groups and the difficulty levels. The other thing is that we don't actually have, as I said, this youngest age group in India. So we don't have class 1 and 2. So problems which are designed for class 1 and 2 can also be typically used for class 3 and 4. And then you have to take a call on the difficulty level of these things. The other challenge comes with administering the contest. So ideally, we would like all the responses. So we saw that there are, lakhs of students, 1.75 lakhs roughly students taking the contest. So it is a big challenge to keep track of who has taken the challenge, what answers they're given, what their score is. So the easiest way to do this is to have an online platform where students actually write their things on a computer, and these answers are captured automatically so that there is no manual recording to be done. But in practice, when we conducted in many of these rural schools, there are not enough computers available for all students to take this in the time available. So the Bebras challenge is not very rigid about the time frame. It's not like a typical competitive exam where everybody has to take the exam at the same time, because the idea is to basically let students do this in a reasonable way and give them some something interesting to do, but without making it super competitive. So usually schools have a period of about a week or 2 weeks to administer the thing. But even then, if you have only say 2 computers, how many students can actually do this? Because each exam, each run of the thing takes around 45 minutes to an hour to administer, because they will typically be somewhere like 15 to 20 problems. So if you do it manually, where students fill out these things, even on a machine readable thing, there is still a challenge with keeping track of who has filled in what, associating the names with the answers and so on. So right now, one of the technical tasks which we are looking at in Bebras India is to actually develop our own online platform. So far, we have been using a European platform, and initially we are using it free, and now we are paying some kind of a service fee to use it. But this is something which hopefully we are capable of designing and deploying. So maybe not this year, but hopefully next year we will have our own platform for this. So one of the nice things about Bebras is that it gives a kind of an interesting complement to just teaching computational thinking in schools. So when we teach computational thinking in schools, this brings a kind of spark, because every student is excited by the idea of having some challenge or contest to measure their understanding. It also gives us indirectly a way of evaluating whether students are actually learning these concepts or not. So you have these diverse problems related to computation, but the nice thing is that there is no prior knowledge required for these. So these students can attempt these problems just based on what they know. And if they, our hope is that if they've been exposed to CT as a subject in schools, they will do better than if they have not been exposed to. But in any case, it measures some understanding of the students' comfort with CT. Also, it's interesting that this is a kind of community effort at an international level. So this is, as I said, a very sharing community, so it doesn't matter whether you've contributed 3 problems or you contributed 15 problems, you are treated on par and your opinions are valued. And also different countries have different challenges with both teaching the subject and administering the exam. So it's useful to be able to compare notes with other countries and learn from their examples, and also give them some ideas about what works for us. So for all the people here, so we had a poll which said that roughly half the people, schools represented in this audience, have taken part in Bebras last time. So I would encourage the remaining 40% who have not taken part to participate. And also, as I said, this is not tied to teaching CT in schools. So even if you know of a school which is not directly teaching CT or using CS Pathshala curriculum, taking part in Bebras is quite independent of that. So do encourage schools that you are in contact with to look at this and take part in this thing. And of course, as a teacher or a volunteer, we always need good problems to contribute our share to the central pool. So do look out for interesting situations that you can capture in this format. So this format is quite rigid in the sense that it must be a simple problem related to computation, which can be captured with, say, one telling picture and a small amount of text. And within that framework, try to come up with interesting problems, and we could always use them. So thank you, and back to you, Sonia.
Yeah, thank you, Madhavan. And you've heard our side on why Bebras Challenge, why should students participate. We have 3 teachers with us, Namrata, Mamta, and Meenal from SOS Beltarodi, who are actually going to share their experiences on not only conducting the Bebras Challenge, but also how they were able to use it later on in their classroom. So I will not keep you waiting because we are also running out of time. So Arun, we have the video, please?
Yes, I will start it. Give me a minute.
Good afternoon to all the educators and facilitators. I, Namrata Morin, along with my partner, Mamta Velkar, express our warm greetings to this elite gathering. We are the teachers from School of Scholars, Beltarodi, Nagpur.
Today, we are here to share our amazing experience about Bebras India Computational Thinking Challenge, updates and activities. In our school, we are having more than 1,000 students in grade 3rd to grade 10. They have participated in the Bebras Challenge. We are having 6 teachers who are involved in taking computational thinking in the subjects mathematics and computers. 2 periods are allotted for computational thinking in our school. We are having Atal Tinkering Lab in our school where students make projects using computational thinking. Let's have a glance about the participation in Bebras Challenge. In 2018, more than 6,500 students took part in the challenge from grade 3rd to grade 8th in 12 schools overall Vidarbha. As when we announced that we are going to have challenge, students were a little bit reluctant and they said that one more exam has to be given. But once they have faced the challenge, they were very positive response shared and they said to their seniors that it is very interesting. So 9th and 10th students came to us and requested that this challenge should be arranged for them as well. So in 2019, we have arranged this challenge for grade 3rd to grade 12 students and more than 10,000 students took part in the challenge. So we can see that there is 40% increase in the participation in Bebras challenge in the year 2019. I am glad to share that more than 50 students got national rank 1st to national rank 10. Here we are having the graph which is showing that in all 12 schools we are having increase in participation in the year 2019. Here are the students' experiences which they want to share with us. Students are saying that the questions in Bebras challenge are very interesting, though tricky, and they develop computational and logical thinking in them. Sneha Dahake says that the questions of the Bebras challenge were complex, it required out-of-box thinking. The unique title of each question makes the task more interesting. Now, I call my partner Mamta Velkar to continue further.
Yes, observing this zealous response, we utilized Bebras challenge to interlink mathematics and computer, and we conducted few of the maths enrichment activities through Bebras. These activities are giving opportunity to explore new ideas and to enrich the subject knowledge of students. So few of the Bebras tasks which were conducted in physical activities are: here is a task. Anita has broken her favorite bracelet and the broken bracelet looks like this. So this is a picture of bracelet. And the question is, which of the following 4 bracelets shows what the bracelet looked like when it was whole? Was it look like A, B, C or D? Isn't it interesting task? Yes. So this task was physically conducted with the students of standard 3rd. They made beautiful bracelets by using colored bits. Have you seen here? These students are totally engrossed here to make bracelets with different patterns. Now here is a second task of Beaver's Resort. Here total 7 houses are there and in each house a distance of 10 steps is there. Kittu, a beaver, is in house number 1. He wants to meet his friends who are in house number 3, house number 5 and house number 7. And the road between house number 6 and 7 is blocked. And the question is, how many steps did Kittu walk in the night when visiting all her friends? So this triggered the mind of students. So we conducted this task physically with the students of standard 7. Students were distributed in group of 5. They individually took part, they practically did it and they reached on the solution quickly because visualization was there and they enjoyed this task a lot. So This made us to explore Bebras challenge more, and so we exhibited Bebras challenge in Maths Corner in annual exhibition. Here are the students of standard 3rd. With them we prepared Bebras task with cardboard and cups. So this is a task of Lisa's board, where Lisa's boards are made with cardboard, and for weights we used cups. And do you know that this was the most visited corner? Many of the parents participated and it was highly appreciated by parents. So these few are the glimpses. Our management given opportunity to showcase this physically in CTiS Megas conference. So teachers demonstrated Bebras task. More than 100 participants took part in this. They enjoyed it, they actually did it, they solved the puzzle, and it was a really nice experience for all of us also. So thus, no prior knowledge of computational thinking is required in solving Bebras challenge. And this was the most interactive session in CTiS Megas conference. This can be enjoyed by all age group.
Yeah, thank you, Arun.
Yeah.
Okay, now since Namrata and Mamta and Meenal told you that this was the most exciting session even in the Mega conference, we are not going to keep you teachers away from it. So what we are going to do is they are going to have you solve the Bebras challenge online. And my request is to all of you, please enjoy it. Please solve the challenge. Yeah, over to you, Mamta.
Yes, ma'am. Just now you have seen Bebras task. So let's have some fun with this task. Here is a task of toothbrush. Here Rinku, Pinku, Bantu, Chintu and Mantu are the beavers going for bed. Mother beaver instructed everybody should carry brush of correct size. So, but you can see here they are not carrying brush of their size. So Mother beaver instructed Mantu and Bantu, swap your brushes. So after swapping, this is the position. Here you can see still they are not carrying brush of same size. So second instruction given by Mother beaver is Rinku and Bantu, swap your brushes. So after second swapping, this is the position. Still all are not having brush of correct size. So now question is for all of you, that which two beavers still need to swap their toothbrush so that all the beavers have the correct brush? Is it Pinku and Chintu, Rinku and Mantu, Pinku and Bantu, or nobody, means no swap? So here, poll question. You need to answer, all of you. So what will be the last swap? So that you need to answer here. Yes. We'll wait more just 15-20 seconds. Answer all of you.
Yes,
This
people
is
are still
really
answering.
a task.
I think I will end the polling now.
Yes, yes, sir. Yes, we can stop, sir. Yeah. Here, most of you have given answer as A. Wow. It's correct answer. Let's see how it is correct. Now,
Here you can see that the last swap is Pinku and Chintu, so that everybody will get brush of correct size. So answer is A, that is Pinku and Chintu. And here it's nothing but computational thinking, abstraction, algorithmic thinking, and decomposition. As we have seen, it is mother made pairs, so it is broken in parts. Stepwise, it is solved and framed the rules. Let's go to the next task.
Here, this is the second task, shelf sort. Here, Sheena is at home during the lockdown period, and just for the sake of fun, she has taken out the articles from the shelf. Now, her mother has instructed to rearrange the articles in the shelf following the given rules. First rule is rectangular items must not be next to each other. And the second rule is circular items must not be next to rectangular items. So, which one of these shelves has followed her rules correctly? Is it shelf A? Is it shelf B? Is it shelf C? Or is it shelf D? Let's have poll.
इंटरफेस अच्छा नहीं है.
Yes, we can end the poll.
People are still answering. Let's give them a few seconds.
Okay, few seconds we will give. Yes, so most of you have given the option D, 80%. So let's see whether all of you are correct here or not. So what is happening in shelf A? We can see these rectangular items are next to each other. So it is not following the first rule. In case of shelf B, this red ball, which is circular, is next to the book. So it is not following the second rule. In shelf C, this red ball is next to this red book. So again, it is not following the second rule. But in case of D, neither the rectangular items are next to each other, nor the circular items are next to rectangular item. So the correct answer is shelf D, and maximum of you have solved it correctly. So let's move to the next question part now. Here we have used algorithmic thinking, decomposition, patterns, and evaluation concept to reach to the solution.
So here is the next task, loading boats. Two fishermen own two boats named Pari and Udan. Each boat can hold a maximum cargo of 300 kg. The fishermen are given barrels filled with fish to transport. The number on barrel indicates its weight in kilograms. Each boat can hold maximum weight of 300 kg. So which barrels should be placed in Pari and Udan so that both together can transport maximum weight? So here are the four options. So you need to choose the correct option following the given condition.
Let's wait for a few more seconds.
Okay, sir. So here are the results. So maximum of you have voted for D option. Let us see. Next slide, please. So here, in option A, Pari exceeds the load by 20 kg. In option B, Udan is exceeding the load by 10 kg. And in option C, both Pari and Udan are exceeding the loads. So the option D is the correct answer. It is following the given condition and it is transporting the maximum load possible, that is together 590 kg. So it's nothing but computational thinking. The skills involved in these tasks are decomposition and evaluation. Did solving these Bebras tasks require any prior knowledge of computational thinking? No, it's not. Students of all ages enjoy these challenges. So I hope you all must have enjoyed these tasks. I am sure that you will make your students enjoy these tasks in class also. We are thankful to CTiS for giving us opportunity to share our experience of conducting Bebras challenge in our school. It is really helpful to enhance computational thinking skills in today's generation and make them ready for the challenges in future. Thank you once again.
Yeah, thank you, Namrata, Mamta, and Meenal for a wonderful session. I hope all the teachers enjoyed it as well. So because we are running short of time, we'll take the question answers in the breakout room. Arun, can you please share the slides? And also a quick reminder to all of you, the next session will start at 8:30 p.m. We have Janet Wing as a distinguished speaker. And please use the same webinar link to join in the evening.
Thank you, ma'am.
Yeah. So just a second so that I can tell you who all will be there. So the links have been put in the chat box. So if you click on it, you will join the Zoom meeting. So room 1, we will have me and Madhavan and Sandeep from AP, Pratiksha, and we will have teachers from Bebras and information representation. And room 2 will have Vipul, TCS GoIT, Preeti and Bhagya, and Geeta, and teachers from CT and Maths. So based on that, you can just click and go to the right link, that the room that you want to watch. Yeah. And that's an informal discussion. You can turn on videos, audios. All of us should talk that, like that's what Venkatesh Raman was saying in the morning. This is our opportunity to meet all of you. And that's why it's called Gupshup Chai Pe Charcha. There's no chai, of course, but please join us for the session. Thank you.
Arun, can you post the links on the
Yeah,
chat
please
session,
post the links.
Okay, I'll do that.
Yeah, just give us a minute. Arun is posting the links. So if you want breakout room 1, it's Madhavan, me, the Bebras teachers and Nandakishore, and the other one has Vipul, Preeti and Bhagya, teachers from CT and Maths, and Geeta from Meghe. So looking forward to meeting all of you there. Just click on the link and you'll be able to join the Zoom meeting. Thank you.